speeding into the fast lane with Globe's 5G technology. It's fast, it's fun, it's wonderful. It's Kim Son-ho approved. With Globe 5G technology, the possibilities are endless. It's about time we inspire the youth to create something meaningful, spark reinventions, and improve the framework of the future. That's what the 5G Hackathon is about. Students, professionals, and startups are welcome to join the event by registering using this link. Once accepted, you may enjoy access to the Globe 5G Hackathon HQ, where the enablement workshops will happen. That's 2 weeks worth of fun workshops and mentorship by industry experts from our tech partners. All these to get you to the top. That doesn't end there. Apply what you've learned from the workshops and pitch your idea on how you can use 5G to improve the way we live. The panel will pick the top 30 semi-finalists to join the pitch competition and enjoy exclusive workshops and consultations with mentors. But if you're truly, madly, deeply at the top of your game, you can be chosen as part of the top 10 finalists who will proceed to the Hackathon Finals. 3 of the best pitches will be hailed as winners. What's in it for you? Well, over 500,000 pesos worth of prizes will be given away, plus a chance to be part of the Venture Builders program of 917's Venture Velocity and work directly with Globe 5G Acceleration Lab. This is powered by Globe and Animal Labs by DLSU. Thanks to 5G, we're about to achieve great heights. Click the link and show us what you've got. Get ready to reinvent your power to create change. Register now.
Do you wanna make a difference and reinvent your world? 네, 안녕하세요. 여러분, 김선호입니다. 샌드박스 같은 곳에서 경쟁하는 기분을 느껴보고 싶으신가요? 그렇다면 글로브 5G 해카톤에서 진행하는 워크숍과 멘토십을 통해 5G 활용 방법을 만들어보고 여러분의 친구, 동료들과 팀을 만들어서 디지털 시대 속 필리핀의 새롭고 흥미로운 가능성을 열어보세요. Follow your dream. Register now.
You watch me do my thing. Reinvent the world, yeah. Choose to be more, choose to be better, choose to evolve, choose to be more, choose to be better, choose to evolve, choose to evolve. Every time the world spins round, reinvent 360. Thinking you gon' miss a good thing, yeah. Show the whole world, reinvent. Nobody should know stand is strong. You watch me do my thing.
Take it to the next level with Globe's fiber, LTE advanced, and 5G mobile connection. Now you have the power to reinvent your world. Globe.
The new mind-blowing Surfer 99?
9 gig? All sites?
For all devices?
Shareable with up to 4 people?
Like my fam? Anywhere they are?
The new mind-blowing Surfer All 99.
Dear Mother, light of the home.
Dad?
Hey, baby!
Greetings, Professor Rodolfo.
May I be absolved from
Math Club tomorrow.
May Globe Virtual Hangouts kasi.
Go and hang out from wherever you are. Just open the Globe One app, choose an event, and click join.
Watch concerts online!
Dance together!
We can do quiz nights.
Yo, let's go! If
If you allow me,
I promise.
To make it up to you.
And repay your kindness tenfold? Truly, your favorite child.
I love you, Dad.
please, babe.
Thank you, sir.
Enjoy your fave events with Globe Prepaid Virtual Hangouts. All together now.
Yes!
Get it? Get it? Yeah.
We're creating an entirely new class of microcontroller. They bring the same processor core that we've seen in smartphones and bring it down into a single chip package for the very first time.
We feel very strongly that we have now provided the foundation of cloud connectivity and security using Azure Sphere. And with that, we believe now, together, we have a springboard for the future.
Azure Sphere builds on decades of Microsoft's experience in security, in productivity, and cloud-enabled capabilities.
Of course, price is at the core of the microcontroller. These are single-chip computers. Azure Sphere has to reach this very, very low price point.
If you are an original device manufacturer and you're already investing in a microcontroller in your device architecture, then with very little additional cost and with low complexity, you can adopt Azure Sphere technology.
Anyone who's building a device should have a no-compromise view on security. The goal for our product is to make this a reality for everybody.
Security is foundational. Azure Sphere security starts in the silicon and continues through the operating system and the cloud services. Experience has taught us that every component matters because your security is only as strong as your weakest link. Connectivity to the cloud creates for the very first time a connection between the device manufacturer and the device, and more importantly, a direct connection to your customers through that device.
It's getting harder and harder to find the software developers that can develop productively for legacy microcontroller platforms. One of the most fundamental behind-the-scenes benefits of Azure Sphere is that it brings the whole Visual Studio ecosystem into the microcontroller space.
What excites me most about this project is the scale. It is billions of new devices every year. And what we have is the capability of bringing and connecting all of these devices to the cloud, enabling new, rich experiences that are going to affect every person and every organization on the planet.
With Azure Sphere, we fully expect to be surprised by the innovative ideas that you invent for the world and for your customers. I can hardly wait.
It's impossible to look away. Every sense is captivated, pulled into the dance of color unfolding before you. This is the unique immersive experience that customers see when they enter a Microsoft retail store. Over 80 of our locations welcome customers like this, with a huge array of video walls. The content displayed on these screens is constantly being updated to highlight new products and campaigns, but updating the content this frequently comes with a lot of challenges. The layout of screens is unique to each store, and filling them requires imagery tens of thousands of pixels wide or tall. A ton of computing power is required to work with this scale of visual content. During the production phase, designers need to preview and iterate on their work. When everything is finalized, each video needs to be rendered, split into sections, and encoded for each and every store. And the entire process requires a massive amount of storage for the many high-res assets, images, previews, and final videos. Originally, we used an on-premise render farm for this, but it was a ridiculous waiting game, up to 2 days in limbo while the video files were rendering and encoding. And if we needed to change anything, boom, clock resets to 0. Our timeline for each new video was a painful 12 to 14 weeks. We needed a flexible, scalable, cloud-based solution, one that allowed creatives to actually be creative while delivering to Microsoft's unique store configuration. We looked into third-party solutions, but they didn't satisfy our needs. Then, the team had a light bulb moment: Azure Batch. With the ability to run design, rendering, and encoding applications in the cloud, it was a perfect fit. So we engineered a workflow with Azure Batch to automate production and rendering, and the results are game-changing. Batch can duplicate the power of hundreds to thousands of on-premise render nodes with virtual machines. The actual process of rendering is computationally intensive. There are many frames, and each frame can take hours to render. With Azure Batch, we can split a job into many pieces, rendering the frames in parallel across multiple VMs and completing the entire process much faster. And with applications like After Effects, Maya, and FFmpeg running on the VMs, we can extend the power and scalability of Azure to every stage of production. On the front end, we use Azure to host a web-based application that lets designers upload assets, arrange layouts, preview results, and finalize content. Before, designers might sacrifice great ideas to avoid a 2-day render, but with the wait time reduced to as little as 30 minutes, they have the freedom to make revisions on the fly and distribute them faster than ever. Virtual machines are created on demand and spun down when the work is finished. Dashboards enable real-time performance monitoring. Hardware specifications can be changed with a couple clicks, and exabytes of capacity on Azure Blob Storage allow the finished files to stay in the cloud, letting us push videos to every store in a matter of hours, not weeks. In total, we cut production time to as little as 2 weeks and reduced operating expenses by nearly 75%. It really is a revolutionary workflow for anyone producing large-scale content. Whatever the application, Azure Batch can make it happen faster than ever before. For us, that means we can focus on creating a stunning customer experience, with everything automated in the cloud.
Microsoft Azure is a private and public cloud platform. You may be familiar with the Azure services that developers and IT professionals use to build, deploy, and manage applications. But how does it work? Azure uses a technology known as virtualization. Virtualization separates the tight coupling between a computer's CPU and its operating system, using an abstraction layer called a hypervisor. The hypervisor emulates all the functions of a real computer and its CPU in a virtual machine. It can run multiple virtual machines at the same time, and each virtual machine can run any compatible operating system, such as Windows or Linux. Azure takes this virtualization technology and repeats it on a massive scale in Microsoft data centers throughout the world. Each data center has many racks filled with servers. Each server includes a hypervisor to run multiple virtual machines. A network switch provides connectivity to the servers. One server in each rack runs a special piece of software called a fabric controller. Each fabric controller is connected to another special piece of software known as the orchestrator. The orchestrator is responsible for managing everything that happens in Azure, including responding to user requests. Users make requests using the orchestrator's Web API. The Web API can be called by many tools, including the user interface of the Azure portal. When a user makes a request to create a virtual machine, the orchestrator packages everything that's needed, picks the best server rack, then sends the package and request to the fabric controller. Once the fabric controller has created the virtual machine, the user can connect to it. Azure makes it easy for developers and IT professionals to be agile when they build, deploy, and manage their applications and services. But this agility can have unintended consequences if unauthorized resources are created, or if resources are left running after they're no longer needed. The solution to this problem is to use Azure's resource access management tools as part of your organization's governance program. That's the subject of the next video in the series.
Good morning, business professionals, students, and professors all over the country. Welcome to a day of learning with Microsoft and Globe. Increasing competition and ever-growing demand for mobile, always-on services challenges organizations to find new strategies to grow profits and gain a competitive edge. Today is a big opportunity to learn from industry experts and to pitch your team's life-changing ideas with the power of 5G. Are you ready to reinvent your power to create change? Welcome to the first ever Globe 5G Hackathon. Let's get this exciting event started with a message from Microsoft Philippines Enterprise Commercial Lead, JP Vicente.
Recent events have served to accelerate digital transformation. With increased numbers of individuals working remotely, there has been an even heavier dependency on the cloud to provide services, connect people, and empower employees. Looking ahead, communication service providers and network operators are facing further rapid transformation through the arrival of 5G mobile networks. 5G offers the ability to connect tens of billions of intelligent devices, densely deployed and generating data of magnitude more to be handled by the network. Aside from the consumers expecting the next great thing, operators will be under real pressure from enterprise customers to move quickly, delivering 5G's low latency, dense device, and high performance capabilities to enable near real-time management and control of critical business operations. Our business model is aligned with your success, meaning our technology is always in service of your customers, your service, and network, providing a secure, intelligent, high-performance hybrid cloud platform along with a broad developer and partner ecosystem. We will not only further accelerate a global digital transformation, but also offer network operators a real and exciting opportunity to monetize their significant and ongoing investments in 5G. We will look forward to many more scenarios we can unlock together in this new 5G low latency compute world. Let me hand it over to the team who will show you how we can do this together.
Thank you, JP Vicente, for your opening message. Everything starts with the ability to connect. Let us begin our Interconnect session as we listen to Microsoft Worldwide General Manager for Communications, Bob Haven, who will walk us through streamlining telco operation with an intelligent cloud.
Hi, everybody. I'm Bob DeHaven, the Worldwide GM for Comms and Media for Microsoft, and I'm really excited for you all to join us on a pretty dynamic session. We're going to talk a little bit about streamlining telco operations and optimizing new service opportunities with an intelligent cloud. And we're going to do this with one of the most talented and sort of senior leaders in this space. That's the Chief Operating Officer for 3UK, but also the CEO of Innovation, Opportunities, and Development for CK Hutchison, Susan Buttsworth. And Susan's one of my favorite people in this industry. Susan, would you just say hello to the group?
Hello to everybody, and thank you for that amazing introduction. I hope I can live up to it.
Oh, more than that, I'd like to take a few minutes, and you are the way you operate, Susan, is very similar to one of my business heroes, Jamie Dimon. You are fearless. You lead without hesitation. You handle challenges candidly and directly, and we're super appreciative of having you join us on the call today.
Welcome. Thank you for having me, and thank you for the high praise.
Great. Well, let's start with just a little dialogue about what you're seeing. So let's start off with, what are the primary forces that are ongoing today in the transformation of your 3UK business, 3UK business, excuse me?
Right. So, businesses are constantly evolving. It isn't a new thing. And at the moment, what's happening is that the speed of change in technology is actually helping to drive that that transformation at pace. But it's really important to remember that this is a business transformation. It's not a technology transformation. The business is enabled by the technology, but if you drive it from the technology, then you won't achieve your objectives. And we have obviously experienced those challenges in the transformations that we have undertaken. One of the things about the transformation and the technology is the way timescales are changing. So we used to be able to talk about things in terms of, years and months and, weeks, etc. Now it's days and hours and, minutes and milliseconds. And those changes are having a huge impact on the way that we manage our business. And that's also going to be accelerated by 5G. So, the priorities for us, or the key drivers for us in transformation from a technology perspective, they're about connectivity. We have to be on. They're about latency. We can't have high latency in our technology. They're about traffic patterns. Traffic is increasing and traffic patterns are changing, and about customer demand. From a business perspective, the drivers are about new products and services. They're about operational efficiency. They're about omni-channel and giving customers the ability for self-service. They're about insights and analytics, and they're about business agility. So I think they're the key drivers that we see definitely in 3UK and also more broadly than that.
That's a pretty impressive summary, Susan. And I see 3UK as the real challenger in that UK market. And you all have done exceptionally well since introduction back in the early 2000s. In fact, I just read that you're actually the sponsor for Chelsea this year in the Premier League.
That's right. And everyone is very excited about that opportunity.
Congratulations on securing that. A couple other questions for you. This whole COVID pandemic has really led to this concept of the telco space or the carrier space becoming almost the hero industry that's kept nations and economies afloat during this tremendously perilous business time. Tell me a little bit about how COVID has changed or accelerated your plans. For example, increased demands on your customer support systems, or just elements of how the COVID impact has really affected 3UK and your operations.
So COVID has brought to keep the focus that we are an essential service. We've always been an essential service. We've always operated as an essential service, but COVID has given that a much more refined and very personal and real definition in being able to support the demands of the community at large. We have had to make changes to support essential services. And we have had some wins, and we've also had some challenges from the demands it's placed on us. People working from home has been a bit of a win because we've been able to obviously sell our home broadband service, which has been, a very positive thing for us. We've seen an increase in digital transactions, and digital transactions are obviously something that we can provide at a low cost to us. So that's also been a positive. Our network, the network resiliency has, it's maintained and it's serviced our customers. And it's helped us generally to keep our customers connected, that we have had a resilient network. And changes in consumer behavior have been both a positive and a negative. So we've seen changing traffic patterns, we've seen changes in time of day, and we've seen movements in terms of geography of where customers make their calls. So whereas you would see during the height of the day in the cities, and then, lower demand at night, and then peaking up in the outer areas where people live. Now you see that there is less impact in the cities and changes in the outer areas where people live. So that's been something that's certainly kept us on our toes. And from a challenge perspective, obviously retail not being open. In the UK, retail was closed for about 3 months, and that's been certainly very challenging. We have some of our services that we outsource to, across the border, and in certain times we were given very, very short notice that, make another alternative offer here because this border is going to be closed, which again has been very exciting. We've seen changes in our prepay base because we obviously don't have the international travellers, and people have converted more to Wi-Fi when they've been working from home. And interestingly enough, the rollout of 5G has attracted a lot of conspiracy theorists. And apart from having no basis in fact, it is also a very challenging thing for us to ensure the health and safety of our field force who are trying to roll out and keep the network connected.
Interesting. I hadn't heard that last one. That's kind of frightening, this conspiracy theory and the social networking that's going on around 5G causing cancer and all that kind of stuff. It's just ludicrous. So
it is certainly prevalent in the UK and has affected not just us, but other operators as well.
So, you originally mentioned a comment about the physical network attributes of what's gone on with COVID vis-a-vis, not central business offices or central cities carrying the load. Now the load is being distributed out into the suburbs on a 24-hour basis, and that your networks have all been designed around the concept of a centralized downtown network where a majority of workers are. I know you guys have transitioned your OSS and BSS platform to the cloud. Tell me a little bit about why you did that and how that's affecting your operations. Is that making you more nimble? Is that enabling you to serve customers better?
Definitely. I guess the greatest benefit was agility, really. I mean, we were one of the early adopters of moving to the cloud, and we had extremely ambitious plans. And, in terms of agility, we were able to go from a standing start to having a off-premise cloud up and running in weeks. And we would not have been able to do that in weeks previously. Because we were one of the earliest movers, it has given us certainly the opportunity to work with companies like yourself to grow together, shall I say, because there is the theory of moving to cloud, and there's then the practical application of doing it. And I think that we are now a little bit closer, having the theory and the practice aligned. But certainly, originally, it was something that we worked through very closely with yourself. The upsides are that cloud, definitely improves time to market. It allows us for rapid growth, and it can reduce development life cycles, and it can help you with your cost management if you do manage it well, because particularly in the areas of test environments, you can stand environments up and turn them off very quickly. What you need to do is you need to manage it, because otherwise it can get a little bit out of control, which would in effect be very costly. It's great for analytics, because analytics is one of those things that has, variable demands on capacity, and so we're able to do the insights quite well. And it enables automation, and even though it enables automation, it's something that we need to work a little bit more to get the benefits from. So that's probably the next pillar that we'll be looking at, as to how to exploit the automation a bit better.
Really great answer, and quite insightful for all of us. Thank you for that. And sort of that that response is predicated largely on, central operations of what you guys are doing. Do you feel the same about enterprise or enterprise opportunities where we're going to market together to create new products to sell into that space? Are you seeing any benefits in that space?
We're certainly seeing opportunities in that space. For the last couple of months, we've been really back to basics, concentrating on getting the fundamentals right to support our customers. But certainly the enterprise area is an area of opportunity for us.
Awesome. Great to hear. My last question for you, Susan. Tell me what's next for 3UK. You guys obviously got the big branding deal with the Premier League and Chelsea. You're a dynamic force in the UK marketplace. You're really making some headway up there. You've redesigned your operations around a cloud efficient model. Sort of tell me what's next for the 12 to 18 months for 3UK.
Well, one of the things that we are very fortunate to have in 3UK is a very, very healthy 5G spectrum portfolio. So we will be very focused on our 5G rollout so that we can turn that asset into a highly productive resource. In the past, we've been predominantly consumer focused, and because we see 5G as a B2B2C opportunity, we do think that gives us certainly the opportunity to grow in the enterprise space, and that's something that we are definitely looking at. We are making a lot of investments in our network and our IT systems, and we have been doing that for a number of years. Over the next 18 months, we want to realize those investments. Network is the bedrock of everything we do. It's our number one priority in the company. And as a business goal, it's our objective to ensure that we give our customers better connectivity every day. And if we combine that with the investments that we've made in IT, where we are really focusing on improving the customer experience, they're the two most important things for us.
Awesome responses. Thank you very much, Susan. Well, that about wraps it up. And I do want to one more time just thank you personally. I really love watching your leadership style. I love your dynamic, can-do. One of the things I looked at several people in your LinkedIn file. You were always defined as up to the challenge or challenge worthy. And so I think you're the perfect chief operating officer under this environment for 3UK relative to their market position and growth objectives. And I could not be more excited to work with you and to continue to develop the success that 3UK is seeing. So just a real pleasure, as always, to spend a little bit of time with you, learning a little bit about what you guys are doing with digital transformation, how you're integrating the cloud into your operations, where you see your next generation of growth coming from. It's just been an absolute pleasure to work with you. We're very proud of our relationship, and I want to thank you for the time today. You've been just marvelous.
You're very welcome. It is actually a pleasure to work with Microsoft. You've been very supportive, and I look forward to being able to enhance that relationship going forward.
All the success in the world to you, and good luck. Let's hope we can meet face to face sometime soon. Take care, Susan.
It'd be very nice. Thank you very much.
Thank you, everybody, for joining us on the call today. I hope you found this insightful. I hope you see Microsoft as a thought leader and a true long-term business partner in the marriage of service providers and global cloud providers. Everyone, have a great day.
Thank you, Bob and Susan, for your enlightening discussion. Now let's move on to the Edge Platform sessions, where our speakers talk about the essence of helping supply organizations with cloud computing options that meet the customer whenever those capabilities are needed. To give an overview to Azure Edge Zones, please welcome Microsoft Principal Product Manager of Azure Networking, Karthik Ananta Krishna.
Hi, my name is Karthik Ananthakrishnan. I'm a product manager in Azure Networking. Going into the agenda for this session, I want to start off with the Azure Edge Zones overview and provide you a view of the different offerings that Microsoft has announced in terms of the Edge offerings. I'll take you into the details of Azure Private Edge Zones, which enables enterprises and telco operators to build private wireless networks. I'll also talk about the Edge Zone partner ecosystem that we have built to enable you to take advantage of the private Edge Zone platform. I'll finish the session with a set of cool demos with the different partners that we have done the technical integration with. The key goals for this session that I want you to take away is really to understand how we are enabling the telco operators to take advantage of the different edge offerings that Microsoft has come up with. I also want to share the details on the work that we are doing with private edge zones that enables you to build private wireless networks, and also to understand how we are bringing in the ecosystem of developers to build edge applications, and how you can build MSP offerings to build a private wireless networks based on private edge zones. Looking into the Azure operator ecosystem and the work that we have been doing in hyperscale Azure, what we wanted to take away is when we are thinking about all the capabilities that we are bringing towards the edge, we want to build carrier grade network functions, which we are able to consume in an as a service type of model. You will get to see a view of that with respect to the private edge zone work that we have been doing. We also want to make sure that the performance and the scalability and everything is consistent in terms of the capabilities that we have built in Azure and what we are taking into the edge with our edge offerings, the developer tools and the CI/CD pipelines and the different DevOps tools. We want to keep it consistent between Azure and what we are building in the edge. And with our recent acquisition of Metaswitch and Affirm Networks, we want to simplify the network operations for the telco operators, and we want to bring in newer capabilities to market quickly with the capabilities that Metaswitch and Affirm Networks offers. Also, looking into the other aspects in Azure on how we have built the global footprint, the security and the trust, we will want to bring the same capabilities towards our edge offerings as we look at the operator ecosystem. So here I want to set some context in terms of what we have announced at this point in terms of all the different edge offerings. So around the end of March, we announced a set of capabilities. The keen focus from a Microsoft standpoint is in terms of technologies like 5G. So if you look at this picture, we have a global footprint of Azure regions, which is a part of the Microsoft backbone. And now we have Azure Edge Zones, which are smaller footprint extensions of Azure's in metro locations. We have then announced Azure Edge Zones with carriers, which is a multi-tenant Azure, which is 1 hop away from the 5G core of a telco's infrastructure. With both Edge Zones and Edge Zones with carriers, we want to bring in edge computing applications, which are mission critical applications, closer to the end user device so that you can take advantage of technologies like 5G. With private edge zones, which is based on Azure Stack Edge, we want to get to the capabilities like private wireless networks, and I'll talk in detail about the capabilities that we are enabling with private edge zones. Looking into Azure Edge Zones, as I mentioned earlier, Azure Edge Zones are smaller footprint extensions of Azure, which is still a part of Microsoft's global backbone, which we are bringing up in metro regions. So these are fully managed from Azure, and you can deploy, just like how you deploy a virtual machine or a container workload in Azure, you should be now able to use the Azure portal and go and deploy your workloads. In that sense, the developer experience is consistent. What we have done with Azure Edge Zones is move compute closer to the user. So if you think about media processing or data processing type of applications, which requires a low latency and a highly available network, by moving compute closer to the user, we are enabling these capabilities. In Azure Edge Zones with carriers, we are keenly focused on technologies like 5G, where we want to move the compute 1 hop away from the 5G core of a telco's infrastructure. So if you think about scenarios like immersive video applications, or if you think about scenarios like infrastructure-less bank or an infrastructure-less retail store, in order to enable these capabilities on a public 5G network, what we are doing with Azure Edge Zones with carriers is embedding the compute one hop away from the 5G infrastructure. So this enables the telcos and the developers ecosystem to be able to build and test the edge computing applications in the big Azure. And then you can identify an Azure Edge Zones with carrier as a location target and deploy it on an Edge Zones with carrier. So this is the work that we have been doing with AT&T, which will eventually expand to all the other telco operators. Going into the details of Azure Private Edge Zones, we believe that the enterprise use of technologies like 5G is going to be in the deployment of private wireless networks. So to enable this for an enterprise to deploy a private wireless network and to enable the telco operators to use a cloud native platform for deploying private wireless networks, we have created a new offering in preview, which is Azure Private Edge Zones. Azure Private Edge Zones is based on Azure Stack Edge. You can now use Private Edge Zones to deploy both a virtual network function as well as an edge computing application side by side on the Private Edge Zone platform. So Private Edge Zones offer capabilities for you to deploy your native VM-based applications, or if you have a modernized application that is based on containers, you can deploy both varieties of applications from the cloud and manage it from the cloud. Similarly, to simplify the network operations for the telcos and bring newer products to the market quickly, we have enabled a simplified click and deploy, a SaaS-like experience for deploying virtual network functions from the cloud and manage it in the edge. I'll show you a couple of demos of the integration that we have done with the different partners that enables this capability on Private Edge Zones. So essentially the key takeaway with Private Edge Zones is, if you think about scenarios like smart factory or smart manufacturing, where enterprises want to run a private wireless network, you can now use Private Edge Zone as a platform to run both the network functions like the virtual packet core, or you can run the network functions like an SD-WAN CPE on the Private Edge Zone platform. And you can also run the edge computing applications which are container-based or VM-based that take advantage of the GPU on the device. And you can run them side by side and enable scenarios with private wireless connectivity. We understand that building a private wireless network is very complex, and it is not easy for enterprises to manage a private wireless network. So in order to enable a telco operator to be able to deploy a private wireless network and manage it for an enterprise customer, we have built an ecosystem of different partners, both on the technology side as well as in terms of offering a managed services. So looking at it all the way from the devices to the SIMs, we have partnered with the different SIM vendors and device vendors. The device vendors are specifically in terms of looking into Sierra Wireless and Multitech, who are bringing in their transition gateways with respect to a CBRS, with respect to an unlicensed spectrum. In terms of the SIM cards and both the eSIM and the SIM technologies, we are partnering with Gemalto, Idemia, and G&D. We have also partnered with CommScope and Nokia in terms of the access point vendors. And looking into the ecosystem of virtual network functions for the evolved packet cores, we have at this point worked with the different industry leaders in this space, like Affirmed, Metaswitch, Nokia, and Mavenir. And we have gotten it to a place where these virtual network functions can run on the Azure Stack Edge platform. So the experience that we have created is you should be able to simply go into the Azure portal and pick an Affirmed or a Metaswitch evolved packet core as a SKU, and you should be able to click and deploy it in a SaaS-like experience onto the Azure Stack Edge and completely manage it from the cloud. In addition to the evolved packet core vendors, we are also working with an ecosystem of SD-WAN CPE vendors like VeloCloud, Versa, and Nuage Networks to bring the SD-WAN Edge as a network function that is available on Private Edge Zones. We are also looking into bringing in firewall vendors like Palo Alto and virtual routers from Arista onto this platform. So the idea being that if you look at the whole technology vendors that we have built in terms of the partner ecosystem, you as a telco operator should be able to use Private Edge Zone as a platform and build an end-to-end private wireless network connectivity plus an edge computing application as a completely vertically integrated solution and take it to the market with your customers. As I mentioned previously, the private edge zones is based on an Azure Stack Edge platform, and I want to talk a little bit about the details of the capabilities of the Azure Stack Edge platform. So at Ignite, we are announcing a new SKU of Azure Stack Edge, which is the Azure Stack Edge Pro that enables private edge zones. With Azure Stack Edge Pro, it is equipped with GPU capabilities, so you can have 1 or 2 GPUs, which is a Tesla T4. And what we have also done from a networking standpoint is we have used SRIOV capabilities on ports 5 and 6. So if you think about specialized network functions like the evolved packet core that take advantage of network acceleration, we now have the capability to enable it on private edge zones with the new Azure Stack Edge Pro SKU. With the GPU capabilities on the device, you can now take advantage of the GPU on the device to light up scenarios like video inferencing at the edge. So if you think about use cases like where there is a raw video feed from a retail store that needs to be processed by an edge computing application, you can now do video processing and video inferencing at the edge using your own custom vision or computer vision models. The other aspect of Azure Stack Edge that I want to highlight here, which my colleague Nikhil will talk through in detail in his session, is that Azure Stack Edge, which enables private edge zone, is now capable of deploying containerized workloads using an IoT edge runtime. So you can use an IoT edge and an IoT hub architecture in terms of deploying and managing edge computing applications, container-based edge computing applications onto the Azure Stack Edge. So think about several branch offices in a retail type of a scenario where if you want your edge compute application to run as a managed application on all the different branch offices and you want to manage them and update them, you can actually do it from the cloud with the IoT Edge, IoT Hub type of a deployment model. Azure Stack Edge also has support for a native Kubernetes containers. So you can use Azure Arc for Kubernetes and a native Kubernetes support on the Azure Stack Edge to build Kubernetes-based container applications at scale and manage deployments across several branches. Azure Stack Edge Pro also supports the capabilities for virtual machines. So this is to enable you as a telco operators are bringing in MEC applications that are legacy applications, and these are virtual machine based. You can now build these cloud native VM based applications and run them on Azure Stack Edge. Bringing it together essentially with private edge zones, what we are trying to get to the telco operator ecosystem is a platform on which you can run network functions. You can also take advantage of the IoT Edge runtime, and you can run a GPU-based applications. So essentially, it's a platform for you to run network functions and edge computing applications that are running side by side, and you can completely manage it from the cloud. So what we are also trying to do is bring an ecosystem of ISVs who will bring their marketplace managed applications that you can integrate and put together a fully integrated MSP offering with which you can bring newer capabilities to the market. So now I would like to switch to a couple of demos to showcase the work that we have been doing with virtual network function vendors and solutions both in the private LTE space and in the SD-WAN space. So for my demo scenarios, I'm going to highlight the work that we are doing with Nokia Digital Automation Cloud and also with Velo Cloud for their SD-WAN CPE solution. We have been working with Nokia Digital Automation Cloud. As you are probably already familiar, NDAC offers a private wireless solution, and NDAC has targeted different industry sectors in terms of deploying private wireless solutions as a part of their offering. So this includes facilities like a wind turbine farm where there is no access to a public LTE spectrum, where a private wireless network is very attractive in terms of managing the operations of the wind turbine farm. There are also scenarios like employee safety and transportation, where NDAC has targeted these scenarios for private wireless network deployments. So Nokia Digital Automation Cloud is a full solution all the way from device management to the different queues in terms of the access point, both indoor and outdoor access points. The work that we have done with Nokia Digital Automation Cloud and private edge zones is to be able to package the Nokia Digital Automation Cloud NDAC Edge and run it as a SKU in our private edge zone marketplace, so that if you go into the Azure portal, you should be able to click and deploy an NDAC Edge once you have done the physical installation of the different access points and the connectivity is established on the Azure Stack Edge, you should simply be able to go into the Azure portal and have a click and deploy experience for the NDAC Edge. And after that, your private wireless network is completely cloud managed. So going into my demo setup, I'm going to play this video where I have a setup in the Nokia offices where we have a Nokia picocell and we have an Azure Stack Edge. And once you have set up a physical connectivity between the Azure Stack Edge and the access point within an enterprise premises, at that point, it is pretty much a click and deploy experience for you to light up a private wireless network. So as I walk through this demo, you will see that I am now going into the Azure portal. Once my initial physical network connectivity is completed and the access points are connected to the Azure Stack Edge, I can simply go into the Azure portal and I can pick my subscription where I want to deploy an NDAC solution. Now, the one thing that I want to highlight here is if you are a telco operator and you are managing the complete private wireless network setup on behalf of the customer, by putting together an MSP offering, you can operate on behalf of a customer subscription in terms of deploying the virtual network function for the customer on the Azure Stack Edge and fully manage it for the customer. You can also integrate with the Azure Resource Manager APIs with your BSS and OSS systems in terms of your marketplace and your digital platforms to provide a fully integrated solution for the customers. So in this demo, I am choosing my subscription. I am also choosing my Azure Stack Edge device. I am at this point providing a name for my VNF that I want to identify in my topology. I pick Nokia as a SKU, and I pick the appropriate SKU from the different offerings that Nokia has created as a vendor. I can also specify the custom IP configuration that is relevant for my enterprise deployment. And once I click on review and create, at this point, we validate your configuration that you have submitted. And once the configuration is validated and you click on the create button, our orchestration and the work that we have done with the NDAC kind of takes the goal state that you specified, and we are able to go and deploy an NDAC edge on the Azure Stack Edge. The work that we have also done is basically to expose an API surface for NDAC as a vendor to be able to integrate with our service to give you a zero-touch automation. Once the NDAC edge is deployed, you can then go into the NDAC portal and you can activate a SIM profile on the network. At this point, the NDAC edge that is running on the Azure Stack Edge now can activate an operational SIM profiles. Then you can go into your end user device, and the end user device at this point is able to access the private wireless network. So we have made it completely easy for an enterprise to take advantage of a private wireless network. So as I walked you through the Nokia demo of the Nokia Digital Automation Cloud enabling a private wireless network, I also want to highlight that we are working with telco operators and SIs in terms of an MSP offering that you can put together that offers either a private wireless network connectivity as a solution, or you can package a private wireless network connectivity as well as an edge computing application for a vertical, say for example, smart retail or smart manufacturing, and your MSP offering can be made available on the Azure Marketplace so that the customers can discover those MSP offerings in terms of a complete solution that you as a telco operator is bringing to the market. Here is an example of an MSP offering that Nokia Digital Automation Cloud has put together on the Azure portal. Now moving on to the other integration work that we have been doing with the different partners on private edge zones with respect to the virtual network function ecosystem. The other one that I want to highlight is the work that we have been doing with SD-WAN vendors like VeloCloud, Versa, Nuage Networks, and other partners. So here I want to highlight the work that we have been doing with VeloCloud. So if you're already familiar with the VMware SD-WAN by VeloCloud, today we have all of these SD-WAN CPE vendors available as a virtual network function in the Azure Marketplace. So you can go into the Azure Marketplace and you can click and deploy a VeloCloud SD-WAN Edge as a network function in the Azure Virtual Network. So now what we are enabling with private edge zones is the ability for enterprises and telco operators to be able to go into the Azure portal and deploy a VeloCloud SD-WAN Edge as a managed network function on the private edge zones. So you have the same click and deploy experience in terms of going into the portal and be able to specify your custom network configuration, and you can deploy a VeloCloud SD-WAN Edge VNF onto the private edge zones basically. So as we look into edge zones and edge zones with carriers, the work that we want to do with VeloCloud is to be able to enable the VeloCloud VMware SD-WAN gateway to run in edge zones or in edge zones with carriers as a part of the SD-WAN overlay fabric. So this is a scenario of VeloCloud taking advantage of the compute infrastructure that is available closer in the metros and in the telcos data centers to be able to run the SD-WAN gateway. So to show you how we have simplified the experience in terms of how you can take advantage of a VeloCloud SD-WAN edge on private edge zones, I want to show you a demo of the work that we have done with VeloCloud. So for my demo setup, I have a VeloCloud SD-WAN edge running in Redmond campus on private edge zones. I have another VeloCloud SD-WAN edge VNF running within the VMware premises. I also have a VeloCloud SD-WAN edge running within an Azure virtual network. So to show you an end-to-end setup of a cloud-managed VNF deployment and the initial provisioning, and after that how you can go and manage it from the VeloCloud orchestrator and also from the Azure portal, let's switch to the Azure portal for my demo. Here I have the Azure Stack Edge device in the VMware premises. The Azure Stack Edge device is a completely cloud-managed device, and I'm now on the Azure portal. You can see that the device is online. Now let me switch to the Properties tab. You can see that the port 2 of the Azure Stack Edge device is the management port on the device, and it is now connected to Azure. And port 5 is the LAN port, which is connected to the enterprise network. And port 6 is connected to the wide area network within the enterprise premises. Now, once all of these port configurations are made and the device is physically connected, you can completely manage it from the Azure portal to deploy virtual machines and containerized workloads. And you can also deploy virtual network functions onto the Azure Stack Edge. So in order to deploy virtual network functions on the Azure Stack Edge, once the device is registered, you then go and enable a role, which is the Azure Network Function Manager device resource. By enabling this role, you now can deploy virtual network functions on the Azure Stack Edge. Now, the work that we have done with VMware SD-WAN is to be able to package the VMware SD-WAN as a SKU into the private edge zone marketplace, so that what you can do is you can simply go into this blade, which is a Create Azure Network Function Manager VNF blade. You can specify your subscription where you want to deploy the VeloCloud VMware SD-WAN VNF. You can specify the resource group and other properties. You can then point it to the Azure Stack Edge device where you want the VMware SD-WAN VNF to learn. And we have packaged the VMware SD-WAN VNF as a SKU into our marketplace. So you select SD-WAN as the SKU type and VeloCloud Edge as the SKU. You can also specify your custom user data configuration and your network IP configuration for the different ports for the VNF VMs. Once you specify these properties, if you click the Create button, we have done the work with VMware and the API integration to be able to orchestrate the deployment of VMware SD-WAN onto private edge zones. So here is a VMware SD-WAN within the VeloCloud premises that is now deployed, and it is in the provision state. Now, once the VMware SD-WAN VNF is deployed through the Azure portal, you can simply log in into the VeloCloud Orchestrator, and you can do a VeloCloud Orchestrator provides you a single pane of management for all your branch office SD-WAN appliances, virtual appliances. Now, here you see an Azure private edge zone VNF running in the VMware premises. I have a similar virtual network function running in the Microsoft campus, in the Redmond campus, and I have another VNF running within a Azure virtual network. Now, what I'm going to do is basically I've switched to the test and troubleshoot tab, and I'm now initiating a live session, a live remote session to the VMware SD-WAN VNF running within the VMware premises. Now, what I'm going to do is, this is running on a private edge zone. I'm going to list an active path, list a path that exists between this SD-WAN VNF and another SD-WAN VNF running within an Azure Stack Edge in the Azure premises in the Redmond campus. Now let me click the run button. Now this shows me if there is an active path between this VNF and the SD-WAN VNF running in the Redmond campus. It will show that I now have, this is the bandwidth that is available for the SD-WAN tunnel. It also shows the latency of the network. So essentially this provides you a single pane of management of all your branch offices from the VeloCloud cloud portal. You can also switch to the Azure portal. And if you go into the metrics, you can look into all sorts of metrics for the device resource and for the underlying infrastructure that supports the VMware SD-WAN VNF. Now, this concludes the demo. I hope you enjoyed this session and you got to learn about the different edge offerings that Microsoft is bringing to the market and how we are enabling the ecosystem of telco operators to take advantage of the capabilities that we are bringing in terms of the hyperscale Azure as well as the edge offerings. To learn more about Azure Edge Zones, please check out aka.ms/edgezones and aka.ms/edgezones with partners. If you want to know more about the Azure Stack Edge on which we have built a private edge zone capabilities, please check out aka.ms/Azure Stack Edge. Thank you.
Thank you for that extensive overview and demo, Karthik. Now that we've had a crash knowledge on Azure Edge Zones, let's deep dive into how to run applications on Azure Edge Zones with Microsoft Product Manager of Private Edge Zones, Nikhil Ravi.
My name is Nikhil Ravi and I'm a product manager with the Azure Edge Zones team. I'm extremely excited to join you today with this opportunity to talk about everything that's happening in the world of edge computing and 5G in Azure. In this session, I'll talk about the work we are doing with our customers and partners to enrich their app development experience on private edge zones. By the end of this session, I'm hoping to provide you with a better understanding of the private edge zone ecosystem, all the edge platform features that are optimized for app deployment, and the tools and solutions Microsoft provides to simplify the development, deployment, and management of an application. But before we get started, I'd like to talk about our motivation for being here today. In Azure, we view ourselves as the world's computer. And while this implies a scalable infrastructure offered at a low cost to customers, it's also about meeting customers where they need help, whether it's in the cloud or the edge. It's about allowing our developers and partners to reinvent their business and doing all of this in a secure and compliant manner. With our recent acquisitions of Affirmed and Metaswitch, we believe we understand the needs of telcos. Our ability to augment this with a rich set of tools and ISV partners can support your journey to uncover new business opportunities. So let's start with the basic question around the need to compute at the edge. With the advent of 5G and the proliferation of IoT, we are seeing cutting-edge applications opening up a whole new set of scenarios. Think of the stocking and retrieval process in a warehouse, controlled entirely by robots gliding along rails in all 3 dimensions. Or think of a worker being able to diagnose the issue in the propeller of an aircraft by using an app to facilitate the real-time rendering of images in the mixed reality device. There are many such scenarios emerging across a variety of industries, and all these scenarios require reliable, ultra-low latency communication, something that can only be possible with edge compute and 5G. Now, as you think about applications running at the edge, there are 3 broad patterns that are being used increasingly. The first pattern is where the application processes data at the edge in real time. Think of a drone sending footage of a street and making a real-time decision on where it needs to travel next. The second pattern is where the application does some pre-processing at the edge and sends a subset of the data it has collected to the cloud to further improve the ML model. Think of a traffic camera that's trained to detect a collision. When it believes a collision has been detected, it captures a video for a minute and sends that data to the cloud. This can now be further analyzed in the cloud to improve the model and redeploy it to the edge. The third pattern is where we need edge processing to remove all personally identifiable information before uploading data to the cloud. Now let's look at how one of our ISV partners is using edge computing to deliver innovative solutions to their customers. RXR is the third largest real estate owner in New York with over 25 million square feet of space in the tri-state area. When the COVID-19 pandemic hit, the company needed a way to help tenants stay safe after its buildings reopened for business. They developed a solution named RxWell, a public health-based data-driven solution that merges physical and digital assets to keep employees informed, safe, and supported during the pandemic. Powered by the Internet of Things and the intelligent edge, RxWell combines real-time computer vision, sensors, AI, mobile apps, dashboards, and in-person offerings to deliver a comprehensive solution. Now, I'll let Scott and Tara walk you through the RXR solution in this pre-recorded video.
Okay, I recognize this. This is 75 Rockefeller Plaza. Is this
Yes, it
RXR
is.
property?
You know, RXR is actually one of New York's largest property owners. They have 25 million square feet. That's with a big M. And that includes some of the most iconic addresses. Obviously, this one, too.
Buildings already have security cameras and sensors and stuff. Where does Azure and IoT fit into that existing hardware?
Well, you know, for me, anything that has electricity is an IoT device. But, of course, every device is not connected. And in those instances, you got to get a gateway. And buildings have cameras, motion detectors, all that. But once I can get them connected to the cloud, we can make your building smarter. And we can take advantage of all this great Azure cloud services. Like, of course, IoT, but app service, stack edge, functions, spatial analysis, static web apps even.
Hey, we're in the lobby.
Yeah, do you check out those cool thermal cameras? You know, they can measure your body temperature, Scott. Let's see if you're actually good to go.
Oh, man's not hot. Never hot. I'm cleared.
Oh, well, that's cool. You know what? We should probably keep the proper distance apart, too.
Okay, so the cameras are analyzing for social distancing.
Oh, but think about it. We can detect whatever we want, right? Azure enables these cameras to detect in real time incoming and outgoing traffic, as well as detect if people are violating social distancing guidelines. Of course, it's all using pre-trained computer vision models.
Now that we have discussed the benefits of edge computing, let's go back to our goals for this session. We'll start with the first goal of helping you understand the role of telcos in the private edge zone ecosystem. Let me start by introducing to the Azure Edge Zone family. These are a set of edge platforms we have built to support the needs of our customers and developers. Depending on the latency and scalability requirements of an application, customers could choose between Azure Edge Zones with carrier, and private edge zones. While edge zones and edge zones with carrier are both multi-tenant infrastructure, private edge zones is a single-tenant offering. All of these platforms will provide the consistent Azure experience that you're used to, while giving developers access to all the great Azure tools and services at the edge. If you're a developer, you could continue using Git repositories to house your code. You could package them in Docker containers and deploy them to a fully managed Kubernetes cluster. You build once and have the option of deploying them in multiple locations with no additional effort. For today's session, we'll focus exclusively on private edge zones. This is a single tenant platform that's deployed on a customer's premises, allowing them to deploy applications and virtual network functions through the cloud. Imagine being able to use the Azure experience to deploy a 5G network on the edge platform and running the RxR solution on the same appliance. With the application and the 5G network running one hop away from each other, that's when you begin to see the true power of ultra-low latency edge applications. I'm now going to zoom into the private edge zone ecosystem and talk about how we are building our service through partnerships. Partners are really key to our offering, and we strongly believe that opening up options to customers will be crucial for market adoption. We are building an ecosystem of virtual network function partners and application partners to provide our customers with a one-stop shop to complete their scenario. These partnerships include a deep technical integration that will allow customers to have a consistent experience with deploying these solutions on Azure and on the edge. We are also making it easier for telcos to assume the role of a managed service provider that can build on the offerings from the VNF and the app partners to put together a package that can further simplify the experience for customers. The Azure MSP model is quite simple. It starts with the MSP partner defining what they want to offer and creating an offering out of it. MSP partners have full autonomy over what they offer and how much they charge for it. Once the customer purchases the offering, the MSP partner can access the required customer resources and provide a fully managed offering. Going back to our goals for the session, let's look under the hood and understand all the great features that the platform offers. Azure Private Edge Zones is powered by the Azure Stack Edge GPU Pro SKU. This is a 1U server with 20 cores of CPU, SRIOV-enabled ports, and 1 or 2 GPUs for customers to leverage. GPUs are a popular choice for AI computations as they offer parallel processing capabilities and are much faster at image rendering than central processing units. You can use the hardware acceleration capabilities and GPU inferencing to run sophisticated ML models at the edge. Additionally, the hardware and software is fully managed by Azure, allowing customers to focus on building apps and solutions. Azure Stack Edge provides multiple compute options to customers and developers. If you have an IoT scenario and are already using IoT Hub and IoT Central, you can use the IoT Edge runtime on the appliance to run containers and have them integrate with IoT Hub. If on the other hand, you need to pull containers from your private repo to deploy your application, you can leverage a fully managed Kubernetes cluster provided in the appliance. And finally, if you have an application that's VM-based, you can either run Windows or Linux VMs on the appliance. You can also run containerized edge versions of a number of Azure services on the platform. You can use cognitive services, for instance, to see, hear, understand, and accelerate decision-making into your apps. Or you could use Azure ML to build, train, and deploy ML models. Azure Stream Analytics is a serverless real-time analytics service designed for mission-critical workloads, and Azure Functions allows for event-driven serverless compute and orchestration. Or, if you want, you could simply deploy your third-party software in a Linux container. Talking about deploying Linux containers, this is possible only because the platform supports a fully managed Kubernetes cluster. For folks that are familiar with Kubernetes and microservices, you know that managing a cluster is no joke. You need to take care of version upgrades, manage the security policies, and ensure you're constantly on the latest version to avail all the features that Kubernetes has to offer. With a managed cluster, all of this is done by the platform. You can also deploy containerized applications of your choice through a few different models. You can use a native tool like kubectl, or you could use a newly launched Arc-enabled Kubernetes to manage all of your clusters and deploy applications through a cloud interface. And we'll get into this in a little bit more detail in just a second. But to recap, you have a platform that's built on a 1U server with hardware acceleration to allow you to run apps and virtual network functions side by side. The platform allows you to run containers and VMs, as well as a number of Azure services to provide you all the features you need to build your app. In this last section, we'll talk about the tools and services that are available to deploy and manage applications on the edge. So let's pick up where we left off at the end of the previous section. We spoke about how customers could leverage Arc-enabled Kubernetes to manage a Kubernetes cluster on the Azure Stack Edge. Let's take a closer look at what this means and what Arc-enabled Kubernetes really does. Imagine a scenario where an ISV has housed their retail application in a private repository, and a retailer wants to deploy the solution in over 100 stores across the country. They want to have a single pane to monitor and manage the health of their clusters across the country, and they want to be able to seamlessly deploy the application to all these clusters with minimal effort. Well, that's exactly what Arc-enabled Kubernetes allows you to do. You can inventory all your clusters across clouds and on-premises servers. You can use GitOps to configure and deploy an app from a single source to many clusters. And you can apply the same security policies across multiple clusters. Let me show you how you could enable Kubernetes on private edge zones and have it show up as one of the many clusters you can manage through Arc. Let's start with an Azure Stack Edge appliance that's been racked and stacked and registered with the cloud service. We log into the local user interface of the appliance here. One of the very first things you'll need to do is configure the network interfaces for the appliance. In the interest of time, I'm showing you an appliance with the settings already configured. The next step is to enable compute on one of these ports. We have done this on port 3, and I'd recommend you pick between ports 3, 4, 5, and 6 for this. You'll need to provide Kubernetes node IPs and IPs for the Kubernetes external service based on the number of applications you plan to deploy. We'll follow this up by logging into Azure to configure the compute role. To do this, click on the Edge Compute section of the Azure Stack Edge resource. You'll have the option of either using an existing IoT hub or creating a new one. Here, you can see the output once the process finishes. This step effectively creates an IoT Edge device for the compute role. At this point, you configure your platform to run Kubernetes and deploy containers. You can now manage your cluster and deploy containers through the IoT role through kubectl or through Arc. In this case, we went ahead and added the cluster in Arc-enabled Kubernetes by running an Arc agent on the Edge platform. You could also add a repository to your Arc resource and use it to deploy containers to your Edge platform. Once a solution has been deployed to the Edge, developers and ISVs need a mechanism to manage their solution. This is where Azure Managed Apps comes in. A developer or an ISV could publish a managed app for their offering, and customers that seek to use their service could give access to the ISV to deploy and manage resources on their behalf. The ISV has full flexibility in defining the manner in which the offering is presented and the service they offer and the price they set. This managed app could be offered through the Azure Marketplace to be used by any Azure customer, or it could be restricted to customers that are part of the same Active Directory tenant by listing it as part of a service catalog managed app. Let's take a look at how one of our partners has leveraged some of these platform features and services to deploy and manage their app on the Edge. Everseen is a global provider of real-time behavioral intelligence solutions. They leverage a proprietary AI platform to digitize unstructured human data and map processes. Their solution can be used at a retail checkout station to prevent fraud, or it could be used at the back of a store to ensure compliance with the process. They have deployed the solution across 3,000 retail stores across the United States and are tracking 160 million SKUs on a daily basis. Now I'm going to pass it on to Norbert from the Everseen team to talk about their solution and see it in action.
Hi, my name is Norbert. I'm an engineer at Everseen, and we are here today in Everseen's immersion lab, where we've optimized our Scenic AI solution to run on-premises using private Edge Zones platform and the Azure Stack Edge infrastructure. Here is a video of the ASC devices currently sitting in the server room. I would also like to mention that we have a private wireless network running one hop away from this application, and both components are deployed and supported using Azure Stack Edge technology.
I'd now like to show you a simulated demo of the Scenic AI solution in action in a retail self-checkout scenario, and we will focus on two use cases, non-scan and product switching. What's happening here is that the camera above the point-of-sale terminal sent a video of the action to the Scenic AI app running on the Azure Stack Edge, and the application detects a pattern of a customer trying to scan, but realizes that no scan has taken place. It sends an alert to the scope. The system shows a replay of the non-scan, thereby mitigating what could be a contentious situation. Let's look at the second scenario of a product switch. This is a scenario where a customer decides to place the barcode of a less expensive product in front of a more expensive product while scanning. Just like in the previous scenario, the Scenic AI solution detects that the product scanned was not the more expensive SKU through the camera feed and alerts the co-host associate to intervene. The system shows a replay of the product switch, helping the co-host in mitigating what could otherwise be a contentious situation. This pattern recognition technology can be extended in many other scenarios, and we're excited about the possibilities ahead of us.
Thanks, Norbert. Let's look at how Everseen has leveraged many of the Edge platform features and Azure solutions we discussed in the session. Their cameras are connected via a private cellular solution powered by a Microsoft Packet Core deployed through the Azure Private Edge Zones platform. Their application uses the GPUs on the box for video inferencing. They also leverage the fully managed Kubernetes cluster on the Azure Stack Edge to deploy their containerized solution. Everseen leverages Azure IoT Central as a single pane of glass to deploy, monitor, and manage the IoT Edge workloads, and the IoT Edge runtime on the ASC to host their AI ML workloads to process and aggregate large amounts of data. Everseen has published their solution on the Azure Marketplace for customers to readily leverage and use for their own solutions. Now, there are many pieces to the puzzle for a customer looking to install a fully integrated solution at their premises. They'll need to decide on the hardware components, the software vendors, their overall solution architecture, while also arranging for the installation and operations of the setup. This is hard work, and it creates a distraction from focusing on their core business problems. Here's where telcos can help. By leveraging the ecosystem and services available through Azure, and then combining it with all the distinct value that only you can bring to the table, you can create a fully managed end-to-end industry offering that can be tremendously valuable to customers. Well, this brings us to the end of our session. I really enjoyed bringing it to you, and I hope you found it informative and enjoyed learning about these offerings. Please take a look at these links if you'd like to learn more, and don't hesitate to drop us a note. Till then, take care and stay safe.
Thank you for your presentation, Nikhil. Cellular connectivity is increasingly important for IoT solutions and represents a vast and generational shift for mobile operators as the share of devices in market shifts towards the enterprise. For our final learning session, let's learn about cloud solutions and Azure IoT. By exposing these services through the Azure platform, we can combine them with other Azure capabilities such as Azure Cognitive Services, Azure Machine Learning, and Azure IoT to bring the power of AI and automation to the delivery of network services. Here to share his presentation on how to use Azure IoT for operators is Microsoft Azure IoT lead, Sam George.
Hi everyone, my name is Sam George. I lead Azure IoT for Microsoft. Today I'm here with you to talk about an incredibly exciting topic for me, which is Azure IoT for operators. You know, the industry is going through a fundamental and disruptive change, and that's including cloud as well as what's happening with operators. And I think it's a time of incredible opportunity for both of us, and we wanted to talk through that. You know, a few years ago, our CEO, Satya Nadella, started talking about this notion of an intelligent cloud and an intelligent edge. And what we mean by that is that the fundamental compute paradigm that businesses use to operate is changing, right? It's not just about the cloud anymore. It's about having workloads that are spread out across the intelligent cloud and the intelligent edge. And what we mean by that is that not just workloads, but also intelligence is distributed across those two. Now, as a solution starts to span cloud and edge, it requires a set of technologies that are used to fuse that into a single unified solution that bridge this gap and make it so that workloads can be pushed out and distributed, that Azure can be the world's computer. And the world's computer just can't run in the data centers. It has to be able to run anywhere on any device. So all these capabilities that are used for fusing the intelligent cloud and the intelligent edge are pretty familiar at this point, right? We have IoT, we have edge computing, we have AI, we have digital twins increasingly that I'm going to be talking about, and then very importantly, 5G. And all of these technologies are in various states of maturity, right? They're all emerging from incubations to mainstream. And our job at Microsoft is couplefold. One is to provide all of this technology, number one, but also we focus very deeply on partnerships. You know, as the world transforms to take advantage of these technologies, as the world transforms to this new paradigm, that is not, in our opinion, a winner-take-all market. That very much requires ecosystems and partnerships to be able to help transform the world's businesses. We understand your priorities as operators. The world is changing, and you're looking for new ways to be able to find opportunities, to be able to reduce your overhead, to be able to take advantage of cloud technologies, to be able to power new scenarios using 5G, to be able to find new margins. And we are very much here as an eager partner to work with you and achieve those goals. Both 5G and IoT have a very, very tight relationship. As we look at this proliferation of solutions that span the intelligent cloud and the intelligent edge, it's very clear that we need breakthroughs in communication, in density. We need breakthroughs in being able to run edge computing anywhere at any network slice between the cloud and the physical devices themselves. And so 5G is incredibly important to IoT, and IoT is incredibly important to 5G. We've been investing in technologies such as IoT for many, many years now. And we also have a set of new opportunities and new investments that we've been making, like the Azure for Operators, as well as things like Azure Edge Zones. And so that's really an incredibly important part of both of those offerings. So we bundle all this and we talk about all this in light of this Azure for Operators, which is really helping our operator partners take advantage of cloud scale economics, take advantage of these new solutions, and really, combine the incredible trust that both of us have been able to offer to our combined customers and provide some really breakthrough capabilities. And I'm going to be talking about that. And I know Julia has already kicked off Azure for Operators, and if you look at the entire stack of offerings that we have in Azure for Operators, it goes everywhere from core connectivity up through edge connectivity and network capabilities. And then importantly, what I'm going to be talking about today is all of the cloud solutions that are available to our operator partners to take advantage of to provide new breakthrough businesses. So you see IoT up there at the top as one of those cloud solutions for operators. So I want to spend a little bit of time talking about what's in an IoT solution, how it's really a big opportunity for our mobile operator partners. And what's happening across the industry is that, years ago when IoT first got started, we saw it being primarily used, and still is today, for connected assets. And what I mean by that is we have companies that are connecting to devices and heavy assets that they had very little visibility into, whether that's elevators, whether that's airplanes, whether that's industrial pumps, whether that's wastewater treatment plants, you name it. There's millions of these types of scenarios, but they're primarily asset-based. And as you connect these solutions that are powered in the cloud out to the IoT devices themselves, or these assets, you're doing things like predicting their maintenance needs, making sure that they're operational, making sure that you have visibility into how they're being used, how to optimize and improve future generations. So everything that we've been doing so far has really been about making it so that companies can take advantage of finding insights and providing better assets. What we're seeing now is a generational shift, not just from assets, but to connected environments. And I'm going to be explaining what we mean by that and what those capabilities look like and what the customers are taking advantage of in those, including Microsoft. And then just over the horizon, we see this shift towards connected ecosystems, where connected environments start partnering one-to-one or many-to-many. And so the world is getting increasingly connected with all of these. And these technologies that I've been talking about so far are really leading the charge. So first, I want to talk about connected assets. So when you're connecting an asset, when you're finding insights from something in near real time that you didn't have visibility into before, there's a huge set of capabilities that are required. You need to be able to securely connect to and manage those assets. You need to be able to store all of that data. You need to be able to rationalize over petabytes, perhaps, of time series data that's coming from that. You need to be able to find insights quickly. You need to be able to trigger informed actions and really integrate that into a business. A connected asset solution is not a standalone solution. It's really part of a larger business solution. So over the last 6 years, we've put together the most comprehensive IoT product portfolio in the industry. We've been rated a clear leader by analysts such as IDC and Gartner and Forrester for all of these offerings. And we've really provided an incredibly comprehensive stack. It starts all the way at the bottom that you see on the slide here from our IoT and edge device support. We have support that can run in as small of devices as tiny real-time operating system devices that run in as little as 32 kilobytes of memory, all the way up through fully operational, multi-blade cloud services that will run disconnected entirely on premises. We have a set of services for IoT that goes everywhere from connecting and managing large fleets of devices with millions of devices in production today, sending trillions of messages every single month. We have data and analytics services. We have business process integration services. I'm not going to spend a lot of time talking about this. Suffice to say, we have everything at the platform capability that our customers and partners have been looking for many years. And we haven't stopped there. We've also been making it easier and easier as we see mass market adoption start to happen for IoT and Edge. We've been providing easier and easier to use services that help any customer, anywhere, any partner take advantage of these technologies like IoT Central. And then finally, we've been going into each industry and figuring out who are all of the partners in those industries, what are their common needs, where can Microsoft play a role, and how can we really create a virtuous cycle of partners doing incredibly well in the Microsoft ecosystem for all of these industries. And all of this secured with Azure Security Center for IoT. Now, I understand that there's a whole lot of names of services that are on this slide. And for now, just know that, we have an incredible set of offerings and leadership position. And more importantly, we have a broad set of developer trainings and certifications. The developer trainings are all free. They're up on the link that you see here, aka.ms, MS Learn IoT. All of those are free, and it covers every single service that we do. So all of your technical teams can quickly get up to speed on best practices for all of the services, the reference architectures, and best practices on putting together solutions. As you go through your learning experience, you can also get certified as a Azure Certified IoT Developer, which just really states that you've gone through a certification process and a testing process to prove that you've absorbed all of that information. Now, a big focus of ours, and I touched on this briefly before, but a big focus of ours is how do we take IoT from the realm of just a few companies that are able to take a very talented cloud solution and embedded developers and produce a solution to how can we mainstream IoT? So a big focus of ours has been, over the last 3 years, has been on simplifying IoT. And two of the most important ways that we've been doing that, first is an IoT plug and play, which I'm going to talk about in a second, and then also IoT Central. And both of those are incredible opportunities for our operator partners. So IoT plug and play bears a little bit of explanation. Today in IoT, what you see is that a lot of companies are wrestling with providing embedded software on an IoT device and having it match a solution in the cloud for that device. And what IoT plug and play does is it simplifies IoT to the same degree that plug and play simplified Windows with peripherals. Now, what's interesting about that is that back in the day, before Windows supported plug and play, in order to use a keyboard or a mouse or a microphone, you had to install specialized software for it. And Windows had to know about that device. Today, of course, you can just plug in anything and it just works. So we're doing the same thing, and it's going to be generally available this year. We're doing the same thing with IoT. And what that is that we have a declarative model where IoT devices can simply say what their capabilities are. Once they've said that, we have sophisticated software in Visual Studio Code where we can actually generate the embedded software for those devices that conform to that. And then that description winds up traveling along through this chain that you see of getting into our IoT plug and play certified catalog. And then any solution like IoT Central and many of our partner solutions that support IoT plug and play can then simply connect to these devices, and the devices simply appear, start sending data. You have dashboards that automatically appear. It really dramatically accelerates IoT. And our hero showcase for where we're showing off plug and play is in IoT Central. IoT Central is also an important part of our simplification of IoT, because what it does is that slide that I showed earlier where you see all of those different services, it uses all of those services under the cover, from IoT Hub and Time Series Insights and all of those services that frankly you don't need to know about, you don't need to care about unless you want ultimate control over those. It takes advantage of all of those services, and all you do is attach devices to it that are plug and play, attach devices to it, and it automatically scales. It automatically grows with the solution, and you don't have to worry about things like high availability and disaster recovery, and did I scale up this service enough to match that service? And so IoT Central takes that burden away from developers and from our partners. It's being used by a lot of our solution developers, and importantly, what we've done is we've made it so that it is not just a fully managed app platform, but that it can be fully white labeled. And what we mean by that is we don't want IoT Central to come through. We want our partners' solutions and their customers' solutions to really shine through. And so we support full white labeling of this. And so you can have an operator-specific, specialized offering built on top of IoT Central that just looks like your own brand, your own unique value proposition, and that comes through. And yet, you don't have to go manage all of those Azure services. It requires no cloud solution developer skills. We also have a very flexible two-tier pricing model that gets less expensive the more you use. So to talk about some of that in action, we have a partnership with Verizon where you see Verizon providing both the devices as well as connectivity, as well as Microsoft providing IoT Central, and then Verizon providing specialized application templates on top of IoT Central. And this combination of devices and connectivity and fully enterprise-grade secure cloud-scale services that are being white-labeled and then vertically specialized is really a magic combination. And what it means is that operator partners such as Verizon and others can get to market quickly. And we've even seen partners on top of that, like Cognizant, that are building on top of all of this between Verizon and Microsoft and offering specialized services on top of that. I mentioned earlier that this is not a winner-take-all market. This is a market of ecosystems and partnerships. And we've been very focused over the last decade of building out a rich set of partnerships, in particular in the operator space and beyond. And so you see some of the folks that we've been working with here in the operator space. For those that aren't on here, we would love to partner with you and make you a successful partner in our Azure ecosystem. I mentioned earlier this notion of a connected environment. It's fairly easy to understand what a connected asset is. Everyone's interacted with one of those or they've seen them. But what do I mean by a connected environment? Well, what we're starting to see is that as more and more businesses are taking advantage of assets, that it's not just the assets they're becoming interested in, it's the environment that the assets operate in. It's how those assets are distributed in that environment. It's the people that are interacting in that environment. It's the processes that are happening. So let me give you a few concrete examples. Many of our manufacturing customers started out as just wanting to optimize the assets in a manufacturing plant and improve the operational efficiency. But as they got good at that, what they started to want to do is to track the entire processing lines that are happening in there, the people that are working on those processes, the supply chain that's coming into the manufacturing plant, and the distribution that's leaving the manufacturing plant. Because all of those wind up being important levers and data points that are needed to optimize it. As you want to track one of these connected environments, the traditional approach that we were providing for connecting assets really needed a new set of capabilities to take advantage of connecting entire environments. I'll give another example of a connected environment, and that's a connected campus with connected buildings. You know, in a connected campus, you're not just interested in the physical assets in it, like the HVAC units or the card readers that are gating access to the buildings. You're interested in providing breakthrough employee experiences and breakthrough service facility experiences for those environments. And I'm going to talk about in just a minute how Microsoft is taking advantage of this ourselves using all of these technologies. Connected environments really represents a massive opportunity for operators. It's a massive opportunity for 5G, for private 5G, and for many of the other things that operators are very good at and are bringing to market, and frankly, we're looking to partner with. So we have a system that we're bringing to market this year. It's already in public preview, and it'll be generally available this year at the end of October, which is Azure Digital Twins. And what Azure Digital Twins is it's a platform service that effectively enables you customers to fuse physical environments with a digital representation of that physical environment. Be that manufacturing plant with the supply chain and distribution center that I was talking about. Be that the connected campus with all of those buildings. And Azure Digital Twins, while it's useful for assets, it goes beyond assets, right? It's not just about the assets in an environment. It's about the actual monitoring and managing the entire environment itself. It enables inputs from things like IoT Central, which we've been covering, or our IoT platform services like IoT Hub, as well as from third-party connected solutions. But then it also plugs into other Azure services, Power Apps, Dynamics, Teams, Office, and many third-party solutions. The insight there is that as you're building one of these connected environments, you're not just interested in the particular assets that are in that environment, but you're connecting to all of the business systems. Now, this might sound theoretical, but we're actually taking advantage of this ourselves at Microsoft. So if you were to visit our Redmond campus today, what you would see is that there's 17 new buildings that are being built from the ground up. And as we're building these buildings, we're building an entire digital replica of them using Azure Digital Twins. To understand why, you have to look at how our real estate and services team is currently managing the rest of the buildings on the campus. And the way that happens is that they actually have many different digital solutions. For example, they have a digital solution for the card readers. They have ones for the HVAC units. They have ones for the shuttles. And as they started looking at, how do we provide new breakthrough employee experiences, what they realized is that those silos fundamentally got in the way, because it meant that if I wanted to build an integrated solution where, I check into the building, as I walk up to a door, it opens because it does visual, it knows me visually. As I walk outside, it'll signal to the shuttle that I'm ready to go to my next building. If you want to do that, you wind up hopping across too many of these digital solutions. And so Azure Digital Twins is not only connecting to some of the new devices that we're putting in our smart campus, but it connects to all of the different vendor-supplied digital solutions. So it really winds up being this integration layer. And for operators, the incredible density of connections to physical devices that are happening in these new buildings from a variety of the vendors is an incredible opportunity. So we're building Azure Digital Twins along with all of our partners that are providing, elevators and HVAC units and shuttle services and card access and building security, and all of them are plugging into our campus digital twin. And then all of that is being powered by 5G connectivity to all of the rich devices that are happening across the campus. Now, with digital twins for us, we very much play at the platform level, but we have a rich ecosystem that's already started of providers such as Bentley, and Bentley builds infrastructure digital twins for smart cities, for smart heavy industry, for roads, for bridges, and they enable municipalities to connect to the digital representations of these, to ask what if scenarios, to make sure that they're being used optimally. And they're building on top of Azure Digital Twins to provide that capability. Ansys is another company that provides simulation services on top of Azure Digital Twins. So it's a rich ecosystem. And frankly, we're looking for mobile operator support as well for Azure Digital Twins for connecting to that rich set of diversity of devices that we see powering these connected environments. Over the horizon, we see the next stage is going to be these connected environments. We're already starting to see, connected ecosystems, and we're already starting to see some of the early signals of that, where you've got some of our companies that are, for example, partnering with power utilities to get lower prices on their power bills by being able to turn off their heavy industry or their heavy power needs equipment in response to pending brownouts. So you start to see as these ecosystems start to get connected, it's going to be an increasingly connected ecosystem world. And I think all of that is an incredible opportunity for operators. We really encourage you to partner with Microsoft, to come build with us, to partner with us at scale, to learn more. We have a bunch of programs for, as I've already mentioned, for learning about our IoT offerings. We also offer things like IoT in a day, where you can spend a single day with us and understand everything that we're doing in IoT at a very deep level. And so I'd encourage you to check all this out. I look forward to meeting you, and thank you for your time. We wish you all the best. Stay safe.
Thank you for that insightful presentation, Sam. Moving on to a discussion on securely connecting billions of devices with Azure Sphere, please welcome IoT Specialist Team General Manager, Anne-Marie Rockwell, together with Principal Program Manager, Tom Patton.
Hi, I'm Anne-Marie Rockwell, and I'm here today to talk to you about Azure Sphere and the Microsoft IoT business. I'm here with my friend Tom. Tom, do you want to introduce yourself?
Sure, Anne-Marie. Thanks. Tom Patton here, also with the Azure IoT team.
So Tom is coming to you from his living room and I'm coming to you from my dining room, but we hope that won't put you off. And we have some interesting things to share with you. Microsoft is focused on the intelligent cloud and the intelligent edge. The intelligent cloud is ubiquitous computing for all your digital feedback. Public cloud and AI allow every type of intelligent application and system that you can imagine. When we think that we've seen every use case and device on the edge, we literally are seeing thousands and thousands of more. The great news about this intelligent edge and its continual expansion is that you can connect all of these devices and applications, gather the telemetry, and analyze it. You can view your data near the data source, near you, or you can do it with both. These real-time insights and experiences are being delivered through highly responsive and contextualized aware apps, which are allowing new business models and new businesses to achieve their growth. When we look at our engagement with our telco partners like you, we're very, very clear in our business model. We're here to partner with you. We are not here to compete with you. We do not have any aspirations of becoming an auto company or a delivery company. And that is really core to our business engagement with you. As we look at the depth opportunity for us with you as operators, we have two things that really kind of ground us. One, we're building solutions with your telco DNA as a foundation. And then secondly, this is all backed by Microsoft's developer ecosystem. Through these business models, we think that we can achieve scale. We can operate hybrid seamlessly. We're going to enable new business models and we're going to allow you to monetize your existing models in ways that you haven't before. And then finally, we are driving for a trusted partnership between you and us. We're going to talk about Azure Sphere now. We're very excited about this product. This is a product that came from the Microsoft Research Group, and we have now brought it to market. Azure Sphere is MCU secured with Microsoft, so we have built security from the silicon up. Let's talk about security when it comes to consumers. Based on the research that we've done, 2/3 of consumers are willing to pay more for products that they know are secure. That's an astounding number. That also lets you think that consumers expect the products they're buying to be secure. 65% of consumers say that they will buy a product only from a brand who has security. If your brand has had a breach, 65% of consumers are saying they're not going to buy from that brand. And then finally, most consumers expect manufacturers to do more to ensure the security of their devices. That's a good segue into the enterprise space. When we look at our enterprise customers, they also expect security in their devices. 97% of enterprises call out security as a concern when they're working with IoT. Through this presentation, we're going to share with you how we can mitigate that. 22% are willing to spend more on their IoT cybersecurity, and 70% of enterprises say they will buy more devices for IoT if they know that they are secure. COVID has actually increased some of this behavior as companies have to do more and more remotely. Remote employees, remote monitoring of their equipment, and we see that as an additional opportunity for us right now. It is changing the way that enterprises do business. What happens if your business is attacked? Or what happens if your devices at home are attacked? It's real. It's a daunting situation. If you're at work, your data is lost. That can cost hundreds of thousands per incident for a company. Nobody wants to have their personal information hacked and used by a foreign or a malicious entity. Data can be polluted and compromised. And then finally, device can be attacked and either enterprise or personal information can be shared. All of this costs money. It costs your reputation. The brand degradation to a company who has had a device attack or has had a data challenge impacts your bottom line. We feel that with the introduction of Azure Sphere, we actually have changed the way that you secure devices. Azure Sphere is built on 7 properties. We have done years of research, and this is the solution that we have to secure your devices from the silicon up. I'm going to just run through these quickly. We have a hardware root of trust. That means that there is an identity between the software and the hardware that drives the integrity of the solution. We have defense in depth. This means exactly what it says. There are multiple layers of defense in our security solution with Azure Sphere. We developed a small trusted computing base. We use everything we know from our many years in the security space at Microsoft. This new OS is built off of a Linux kernel, and it has taken in all of our learnings from Xbox and Windows. So this is a new unique OS specifically for Azure Sphere. Dynamic compartments, again, it is what it sounds like. The MCU is divided into dynamic compartments to drive additional security. We have certificate-based authentication. And then finally, we have error reporting, which is very important because it allows us to see what is actually happening to the devices. And then with Azure Security Service, we have an ongoing renewable security. So we will continue to secure the device. This is very important because when you buy a secure device today that does not have renewable security, it means that as technology and as threats continue to advance, your product or your once secure device is staying static. We are using Azure Security Service to ensure that we're continually updating those devices based on what we see in the market and what we see as a need. To net it out, we look at Azure Sphere as having 3 legs of a stool. You have the hardware, so the silicon. You have the software, so the customized Azure Sphere operating system. And then finally, you have the Azure Sphere Security Service, which continues to drive the security. The business model for Azure Sphere is the chip, the OS, and the S, and we will stand behind the security of that device for 10 years. When we think about Azure Sphere, the promise is very simple. We are working to protect your data both physically and in the infrastructure of Azure Sphere. This is really a game changer in the IoT space. Through Azure Sphere, you can connect your devices and equipment. And in the enterprise side, in manufacturing with Azure Sphere, and you know that Microsoft is backing your security for the 10-year period. I want to go a little bit deeper into our silicon ecosystem. We're very excited about the partners that we're working with today, but I can tell you we have a lot more partners that will be coming online with us in the very near future. Looking at our partner stack today, we have MediaTek. They have the MT3620. We're excited about this product. We had general availability in February 2020, and this is actively being sold in the market. We've also partnered with NXP. We are really thrilled with this engagement. And NXP will be bringing Azure Sphere to market as part of their IMX8 family. What we get with the NXP chipset are more experiences. We're going to add, or we have added AI, more graphics, and also we're very excited because it adds video. With this combination, we open up a whole new section of the market for ourselves. This will give us the opportunity to really engage with security and surveillance companies, and also think about that from a smart buildings, smart spaces, smart cities. So with NXP, we're really opening up the TAM for our Azure Sphere product. And then finally, and this is really the area that I think you, the operators, are going to have the most success. Not saying that you're not going to have a lot of success before here, but with Qualcomm, we're bringing to market cellular on chip. This is super important, and I'll go into the difference in the business models in just a second. I want to draw your attention to the bottom of the slide. We have partners today who are both building Azure Sphere Guardian devices and Azure Sphere security solutions. We have a very long list, but this is the short view. We have Avnet, Seed, AI Link, and USI. And I also have a list of all of the partners that you can work with immediately towards the end of the deck. Okay, I talked about the 2 business models. When we look at Azure Sphere and we look at enterprises and their digital transformation, we see a huge opportunity to connect already existing devices and equipment to the cloud. So I talked about this at the beginning, the ubiquitous cloud. This allows us to connect what's on the edge to the cloud. With the brownfield solution, we are using Azure Sphere Guardian devices to connect already deployed equipment. The reason why this is happening is because enterprises don't want to make the capital investment to buy new equipment and devices that have connectivity, secure connectivity already inside. If they were to do that, it would take literally decades and unknown cost to replace it. So with Azure Sphere, we are connecting what is already there. Think about it in terms of coffee machines, in terms of kitchen, in terms of manufacturing equipment. By using Azure Sphere to connect this equipment to the cloud, I can now perform predictive maintenance, get huge arrays of business insights, and start to drive the digital transformation of my business. On the greenfield side of the business, this is where we have Azure Sphere chip inside of the device. Think about this as smart appliances, your smart fridge, your smart cooker. I love it when they say the laundry experience. I don't have a laundry experience, but I would like to have a smart washing machine. The number one reason consumers do not connect connectable devices is because of provisioning. They can't remember their Wi-Fi password. They're not sure if they should connect it to their Wi-Fi password. But with Azure Sphere cellular solution, we will be able to bypass this provisioning issue with zero-touch provisioning. We see this as a huge solution solver for the appliance manufacturers in the world and also for you, the operators, opening up a brand new business. There are literally billions of units in the world that need to be connected. So how does it work? It's actually very, very simple. What you have is Azure connects to your devices and it connects to the cloud. You do not have to be an Azure customer. You don't have to even use Azure. What we see today is that there are very few enterprises that have a single cloud vendor strategy. So the great thing about using Azure Sphere is it can connect very easily and efficiently to Azure. But if you have a multi-cloud strategy, you can also connect it to any of the other cloud vendors that you have. While the devices are connected, we will continue to update them and track them with the Azure Sphere Security Service. So you know that the device that you have connected over your network will continue to get the security upgrades from Microsoft. So I think I have exhausted you with all of this talk about Azure Sphere, and we really want to get into what's in it for you and how you can monetize and drive these new business models with Azure Sphere. With that, I'm going to hand it over to my colleague, Tom. Tom, do you want to take it from here?
Absolutely. Thanks, AMR. That was really informative. So AMR shared with us how Azure Sphere and the Azure Cloud together really help enable that digital transformation for our joint customers. And I'd like to kind of dig in a little bit and talk about how cellular relates to this and how we think about growing cellular opportunities together. So we've been working with operators around the world and looking at the marketplace and, super excited about what the future brings with 5G coming online and low power networks emerging globally. This is really opening up some new scenarios for IoT to impact our joint customers. Now, although these trends are growing, the overall pie is getting bigger. The component of that pie that is represented by connectivity spend is getting smaller over time. You can see that with this information from the GSMA. And so one way that we believe we can mutually capitalize on that growth and on those new scenarios that are being unlocked with 5G, with low power networks, is to consider together offering joint application platforms, managed services, or even complete vertical applications. And one way that you can accomplish that is by working with Microsoft and our ecosystem of partners to get there. So let's talk about some of the use cases for the Guardian module when we're looking at these more complete solutions that we can go to market together with. The Guardian module is combining together the Sphere plus cellular capabilities into one unit, and that's going to be attached to different assets that are out there in the environment. So you want to think about places where those assets are substantially valuable, hundreds or thousands or tens of thousands of dollars in terms of those assets for these sort of brownfield scenarios, and assets that are being deployed into an unknown network environment. So for instance, if you're deploying an asset into a store, into a hospital, into an environment where you need to be able to monitor that, but you don't have direct access to the connectivity environment, the network that's there. Those are the kinds of scenarios that we want to look at. And then things that just move around in the environment. Obviously, cellular is going to be your best bet for those kinds of scenarios. And so what we've seen is connecting up these sort of unconnected products out there and starting on a journey where we start with, basic condition monitoring, moving up to connecting that into customer sales systems where they can be upsell or service can be provided, and then taking advantage of things like predictive maintenance where we can look at the usage patterns of these assets and make recommendations for maintenance activities. And then finally, we see a great opportunity together to move forward with transitioning the industry of high value assets into product as a service scenarios where we can offer a combined product and service in one OpEx expenditure model. So those are some of the big areas where we're seeing traction with Sphere and the Guardian module. And just to kind of recap on this brownfield opportunity that Anne-Marie touched on, this is taking the device that you've got existing in the environment today, whether that's a crane or a coffee machine. There's probably an existing connectivity port on that device, whether it's Modbus or a serial port. And, typically somebody's got to actually show up, a technician or something, and physically be with that device in order to get the telemetry off of it and take actions, resets, update firmware, etc. That's where this Guardian device comes in with the Sphere inside, which can then connect it seamlessly into the Azure IoT cloud environment. So if we look at one scenario there, we take that entire package, and on top of that rides the rest of Microsoft's Azure IoT portfolio. For instance, you can have our Azure IoT Central on top of that. We are working with partners, with telcos and other partners to be able to resell IoT Central through our reseller programs like CSP. That on top of that has additional capabilities like industry templates for various industries so that the moment you fire up your IoT Central environment, you already have a jump start on what you need in order to make digital transformation a reality for those. And then other platforms and tools that we have at Microsoft where we can assemble a really complete offering, whether that's our Power Platform for low-code, no-code development, or Dynamics 365, Microsoft Teams, or other things that can make this solution complete and accessible to our customers. So let's talk about one example where we've had success with this kind of a model, and that's with Starbucks. So if you think about those cases where you've got valuable assets deployed in environments where maybe you don't have access to the network. So for Starbucks, for example, they've got their own stores where they obviously control the Wi-Fi and can hook their devices up and manage them in that manner. But they also are deploying machines into environments that they don't have direct control over, things like stores and malls and airports and things like this. And in those cases, the Azure Sphere and Guardian module allows them to really save a lot of money and deliver a better experience to those customers and through to their end customers, really delivering the perfect pour every time. So for example, it used to be that a technician has to show up to update the recipe for coffee as new drinks are rolled out. Now this delivery can happen over the air using the Azure Sphere and Guardian module and the Azure IoT platform to make those changes, whether that's updating firmware, updating recipes, or understanding the conditions and maintenance schedule for those machines. So back to you, Anne-Marie, maybe for some details on what comprise these Guardian devices.
Thanks, Tom. It's great to hear all of the use cases and opportunities for telcos. And as I mentioned earlier, we have a slew of partners that we're already working with. What you can see here is really just the top of the list when it comes to the Azure Sphere IoT cellular Guardian devices. These are from companies that we work with, that we have worked with on the design and on the technology. And these are just the first round of partners that we would promote and offer to you as partners as you come to market with us with Azure Sphere. So how are we going to do this? What we would like to do is partner with you. We want you to build with us. We want you to build your Azure Sphere business with us and your Azure IoT business with us. We want to partner with you to take that business to scale, both through our joint enterprise customers and through our enterprise customers. And then finally, we want to sell with you. We want to work with you so we can activate the Microsoft sellers to sell your solution, and then also activate your sellers and channel to sell your solution. So that's where our presentation ends. I want to thank you for your time and for listening. And Tom, do you want to say a few closing words?
Absolutely. Looking forward to partnering with all of you to see how we can together bring more digital transformation scenarios using cellular technology in our IoT platform. Thanks for your attention today.
Thanks all.
Thank you, Anne-Marie and Tom, for your presentation. Now let's hear the presentation of Microsoft Senior Cloud Advocate Anthony Bartolo on connecting your physical environment to digital world.
Hello everyone, and welcome to the Connecting Your Physical Environment to a Digital World, a Roadmap to IoT Solutioning session. My name is Anthony Bartolo, and I am a Senior Cloud Advocate here at Microsoft, based in Toronto, Ontario, Canada, with a passion for connecting people, places, and things for the enablement of everyone. In this session, there will be a brief introduction to IoT and Microsoft's Azure IoT offering, a discussion around IoT solutioning, understanding the opportunity, including the appropriate parties before harnessing the technology, and a look at a real-world implementation of Azure IoT. Let's go ahead and get started. So just what is the Internet of Things? The Internet of Things really comes down to four key things. Physical things that, such as line of business assets, including industry devices or sensors. Those things have the ability to connect to the Internet or to other humans. Those things have the ability to collect and communicate information. This information may include data collected from the environment or inputted by users. And the ability to take the information and provide analytics that comes from this data to enable people or machines to take action. IoT has been seen as the innovation that enables new opportunities. With the introduction of cloud computing, IoT devices can be connected to globally available unlimited compute resources. These resources can harness signals from a plethora of sensors and devices which can be managed centrally by the cloud. New advancements in edge computing and AI can now offload intelligence to the edge, capturing only the result and not the raw data from said IoT devices. And finally, digital twins represents a new opportunity to create living replicas of any physical environment, track the past, and predict the future. Given our work with these types of customers, we've learned a lot in terms of our implementations of IoT. We've seen customers realize big benefits from using IoT to transform their business. But we've also learned that IoT projects can be complex. They can be long and drawn out, and they can take several months to complete a simple POC, or proof of concept. One of the hardest problems is scale. When assets are spread all over the place, connecting to these devices, thousands and millions of them, and ingesting the data from these devices can be complex. Lastly, it's no good to have an IoT solution that cannot integrate with your existing business system. And some of these solutions that are out of the box can be hard to customize and fit to your business needs. So let's show you how we're solving these opportunities with Azure IoT services. With Azure IoT Services, Microsoft gives you a very comprehensive solution that's designed to help you connect your devices, whether it be a few hundred or millions across the world, analyze all the data coming back from these devices, and take action from the insights by integrating with your back-end systems. Azure IoT Services offers the following capabilities. Device connection and management, the ability to connect to millions of devices simultaneously. Enhance security of your IoT solutions by taking advantage of per-device authentication to communicate with devices that have appropriate credentials. Revoke access rights to specific devices to maintain the integrity of your system. Data ingestion and command and control establishes reliable bidirectional communication with these assets, even if they are intermittently connected and analyzed on an act-on basis on incoming telemetry data. Workflow automation. enabling the ability to integrate with your company's existing backend systems to enable the best use of data and processes you already have, whether it's simple as sending a text or integrating with your CRM or EPP systems. Dashboards and visualization, creating powerful and rich visualization experiences with tools like Power BI to view the larger picture of what your data is telling you. And finally, pre-configured solutions. One of the biggest value Microsoft can provide is helping you develop IoT solutions faster. This will not only allow you to do more proof of concepts and pilots, it will also help accelerate the long project cycles we spoke about earlier. We do this by offering pre-configured solutions for the more common IoT scenarios. So now we're going to walk through a real-world example of Azure IoT services in use. In this proof of concept, a team of 5 were given 48 hours to address an opportunity with Microsoft's Azure IoT services. The team selected to address the opportunity of pest control. Rats, mice, and other vermin have been a huge problem in many urban areas. They have the capability of spreading over 35 diseases and can cause potential business loss if reported that mice were visible at their establishment. Understanding the opportunity provided the team with proper foundation to build the IoT mousetrap solution, as there was a clear benefit this solution would address. Pest control companies would greatly benefit in being more proactive in the placement and clearing of traps. This would also provide an opportunity to increase revenue and reduce costs in worker hours and gas by catching more mice effectively. Let's take a look at the design of the automated mousetrap solution and what Azure IoT services were used to architect it. As mentioned earlier, IoT solutions can be complex. Something as simple as a smart mousetrap can be a daunting task to address. Let's take a moment to break this opportunity down and cover the Azure IoT services that make up this solution. At the core, the Mousetrap IoT application consists of the following subsystems. Devices, in essence the mousetrap, that has the ability to securely register with the cloud, and connectivity options for sending and receiving data with the cloud. A cloud gateway service, or in our case, Azure IoT Hub, to securely accept that data and provide device management capabilities. Stream processors that consume the data, integrate it with your business processes, and place the data into storage. And finally, a user interface like Power BI to visualize telemetry data and facilitate device management. So here is the Raspberry Pi mousetrap in all its glory. As you can see, the construct is simple. When the trap captures a mouse, it sets off a trigger, which sets off a bunch of tasks in motion. These tasks include the time of the trap being set off, the placement of the trap assigned by the mobile app, and the placement of the trap via GPS inside of a building. This project has been made available as an open source project and can be reviewed at aka.ms/IoT10/mousetrap. Alright, now it's time to dive into our demos. For our first demo, we are going to go ahead and set up an Azure IoT Hub. Once the IoT Hub is created, we will connect a Raspberry Pi to the service and begin capturing information. What is great about this demo is that you too can participate in this demo via Microsoft Learn for free. Links to this demo will be shared at the end of this presentation. Now, Raspberry Pi boards are popular IoT devices for education, for testing ideas, and even for building some worthwhile systems. Although the cost of a board isn't prohibitive, we can test the Raspberry Pi functionality before investing in actual hardware. Microsoft has built an online Raspberry Pi Azure IoT simulator, which allows users to control the emulated hardware via code. In this example, we will be using the emulator to simulate the capture of data pertaining to temperature, humidity, and pressure sensor, and a red LED pulse to boot. The emulated breadboard even contains a BME 280 sensor to capture the required data. Also, take note that the displayed side panel enables users to enter Node.js code to control the LED and collect the dummy data from the simulated sensor. We will also be using the side panel to add the IoT Hub key to enable a secure connection between the simulated Raspberry Pi and the IoT Hub. So let's get started. Here we are in the Azure Services portal. As you know, access to all of Azure services begins here, and Azure IoT Services is no different. On the opposite side is the Raspberry Pi Azure IoT Online Simulator, which will simulate the capture of data pertaining to temperature, humidity, and pressure as mentioned earlier. Our first step will be to set up the Azure IoT Hub to register the devices. This will be followed by harnessing it to capture the information from the emulated Raspberry Pis. To do this, simply enter IoT in the search bar above and then select IoT Hub to get started. In the IoT pane, you're going to be entering the following information into your IoT Hub. Subscription. Which subscription are you going to be using for this demonstration or proof of concept? Resource group. IoT Hub name. Make sure that your IoT Hub name is unique. You want to ensure that you have the green check mark before you move forward. Once we've selected review and then create, it'll go forward and take some time to create the new Azure IoT Hub. Of course, we've sped it up for this demonstration. As you can see, you can actually download the deployment details as well to replicate your IoT Hub creation, as well as next steps are made available in terms of step-by-step instructions right through Azure Portal to get understanding of what you can do next in adding devices to Azure IoT Hub. Select Go to Resource when the deployment is complete. We also have a graphical representation of our IoT Hub in terms of connected devices and the information that it is sharing to that hub. Currently is empty because we haven't connected any devices to it. That's our next step. So selecting IoT devices, we're now going to add an IoT device to connect to our IoT Hub. We're going to enter a meaningful device ID, which will identify the IoT device that we're going to connect. And we're going to allow for the solution to auto-generate keys for us to use as a connection string to the IoT Hub when we're plugging this into our Raspberry Pi. When this is completed, we're going to go back and we're going to copy the primary connection string information to a text file to use in the next section. Next, we're going to navigate back to the Raspberry Pi Azure IoT Simulator and replace the placeholder in the line 15 with the connection string for Azure IoT Hub service from the text file. We're next going to select Run or enter npm Start in the console window to run the application. You should now see an output being emulated as it shows the sensor data and messages sent to your IoT hub. Also notice how the LED flashes each time a message is sent. When we navigate back to the IoT hub pane, you can now see that the metrics are reporting that the device is connected and the IoT hub is receiving messages. Metrics, located within Azure IoT Hub, provide further information about the state of Azure IoT resources in your subscription. This is currently showing as 0 because no devices are connected to it. You also have the ability to report out specific messages that are coming out from your Azure IoT Hub devices directly from the IoT Hub itself. And that's the end of the Azure IoT Hub demo. This is a visual representation as produced in Power BI that represents the mice being caught and what areas in the building they are being caught in. The visuals are interactive and provide device-specific data in terms of the length of time it took to catch the mouse and the length of time it took to pest control company to clear the traps within both a specific room and the building itself. This report offers suggestions on better placement of the mousetraps within rooms of a building via color coding. It also takes into consideration travel time the pest control company would need to complete to clear said traps of vermin. Next, we will look at how the data is fed into Power BI to be visualized. For our second demo in this presentation, we are now going to feed the Azure IoT Hub data into Stream Analytics, and finally visualize the output in Power BI. Visualization is important as it provides an easier way to view the data your IoT devices are capturing. In the case of the mousetrap solution, the data is being fed into a machine learning workbench to analyze the data first before outputting the results of the data through Power BI. We will not be showing the Azure Machine Learning Workbench in this example since we are specifically focusing on Azure IoT Services enablement. Do know that the process to feed information into Azure Machine Learning Workbench is in fact similar as it would be where the created output would be pointed to for data ingestion. Again, this demo is offered as a Microsoft Learn module, allowing you to participate for free. Links to this demo will be shared at the end of this presentation. Let's begin with this demo. So here we are back at the Azure IoT Hub from earlier. As you can see, the hub is still receiving data from the virtual Raspberry Pi we set up earlier. Our next step is to set up a Stream Analytics job to both ingest and output the data being captured by the Raspberry Pi device. To accomplish this, we simply click on the search bar and enter the word Stream and select Stream Analytics Job. We'll need to add a new job which will require a job name, resource group, and location. Also take note of the hosting environment selection. This solution will stream data from the cloud, but data can also be streamed on the edge should the endpoint device support it. Once completed, we would click Create, but I have already created the Stream Analytics job, so we'll use that instead. Inside of our Stream Analytics job, we'll need to set up an input, a query, and an output. The query is what pulls the data from the input, pushes it to the output, and is customized by you to meet your data reporting requirements. We'll start with the input first, which has already been created. You are expected to provide the input alias. The Azure IoT Hub section is auto-completed based on what is offered in your Azure subscription. The endpoint is set to messaging to feed data to the query. Next, we'll create the output. This will require you to submit the alias workspace, dataset name, and table name. This is where the data will reside once pulled via the query and made ready for the output in Power BI. Next, we set up the query to pull the desired input data to be pushed out to the output for visualization. Again, this can be customized to pull data or push data to multiple sources, and the selection can be customized based on need. As you can see, the input is capturing the data still being delivered via the Raspberry Pi we set up earlier. With the query now created, we can go ahead and start the Stream Analytics job. In Power BI, we would capture the output data set as provided by the same subscription. Our device has not been transmitting data for long, so the visualization of temperature and humidity is kind of small. This data can be visualized in many different chart formats, and a free trial of Power BI is also available to allow you to complete this lab at home. And that is the end of the Stream Analytics job and Power BI visualization demo. So let's take the mousetrap solution a step further. With the information on where the mousetraps have been placed and how many mice have been captured, we are now able to predict the best places to place the traps to catch the most mice. What if we wanted to speed up the learning process in terms of the best places to set the traps? Enter the concept of digital twin, a virtual representation of a physical environment that brings in data from a variety of sources, or in our case, mousetraps. The digital twin concept can be broadly applicable to modeling all the ways we live and work in our physical environment. Modeling the complex interactions and high-value intersections between people, places, and things can unlock new opportunities, create new efficiencies, and in our case, improve the ability to catch mice. The solution uses Azure's Digital Twins Cloud, AI, and IoT capabilities to model a building that traps would be placed at, track real-time data, and provide prediction of mouse capture in a virtualized model. Innovation is a journey without end. People and organizations are constantly pushing the possibilities of our physical and digital worlds. Worlds that are increasingly converging, driven forward by technology from cloud to the edge. AI and IoT are now allowing us to create digital models of our physical spaces, creating the stories, touchpoints, and solutions by realizing the relationships and interactions between people, places, and devices. With the promise of AI, we can uncover insights that see problems before we experience them. We can better understand the needs and improve the experiences that our people want. We can see, learn, and even predict how people move through and interact with the spaces around them. Connecting these stories and data to power modern businesses, building new possibilities in real time. This is made possible by Microsoft partners and an end-to-end Microsoft Cloud offering to help bring to life smarter spaces that connect to a digital world and turn new possibilities into new realities. Microsoft regularly participates in proof-of-concept projects as a way to test new theories on how new Azure services can be adopted. Projects like the Mousetrap solution also provide customers and Microsoft engineers a unique way to upskill on said technology. What is special about the Mousetrap project, though, is that the design, architecture, both machine learning and infrastructure, and code have been made available as an open source solution. People and organizations have taken advantage of this and have harnessed the solution to address other opportunities. An example of this is a recent project that has taken the same architecture and tied the trigger to the music played on an ice cream truck. These trucks frequently travel around major cities here in Canada during the summer months to sell ice cream. Now, the drivers who have been selling ice cream for a while know all the best places to sell the most ice cream. However, as gas prices rise and the operation of the ice cream truck becomes more expensive, the margins for selling ice cream become much smaller. Ice cream truck drivers were looking for a better way to service their customers and keep their overhead low to ensure that they can make a profit. Local developers stepped in and devised a solution based on the open source offering of the Mousetrap solution. When servicing customers, the ice cream truck driver stops playing the music on the loudspeaker to be able to hear the customer's orders. With the trigger of turning off the music now enabled, information regarding the geographical location of the ice cream truck is captured, along with how many sales were completed at that stop. This data, along with weather data and proximity data to surrounding fuel refill stations, is fed into machine learning to understand the best practices to service the ice cream truck driver's customers at the lowest operating costs. Predictive analytical results of this data enables the ice cream truck driver to be more proactive in traveling to areas to service the most customers while keeping operational costs low, and is visually represented via Power BI on their tablets in the ice cream truck. So there was a lot covered in this session, and as mentioned during this presentation, all the live demos of connecting IoT devices to IoT Hub, as well as feeding information from IoT devices to streaming analytics, are available for you to replicate and practice. This deck and other resources are going to be made available with the links that are provided in front of you. This will provide you full-on access to this deck, the videos, and the step-by-step instructions on how to complete the labs that were presented. To also further assist you in your learning, we have curated a collection of modules on the Microsoft Learn platform pertaining to the topics in this session. The demos that were delivered within this presentation actually use Microsoft Learn technology to allow for step-by-step instruction and free replication of that information and creation of IoT services. These modules will also allow you to interactively learn how to securely connect IoT devices to the cloud, how to implement streaming analytics in the cloud, and detail how to create quick proof of concepts with Azure IoT Central. For those of you who are unaware, Microsoft Learn is a free hands-on resource that provides step-by-step instruction to these demos as well as other Azure IoT labs. No Azure subscription is needed for the majority of the Microsoft Learn modules and the learning paths offered. Again, my name is Anthony Bartolo, Senior Cloud Advocate with Microsoft, and if you want to reach me, you can find me on Twitter at WirelessLife. Thank you for attending this session.
Thank you, Anthony, for your presentation. With that, it's time to unlock new insights with AI machine learning with Microsoft Senior Advocate Henk Boom.
Welcome to the presentation, Adding Intelligence. Unlocking new insights with AI and machine learning. My name is Henk Boelman, Senior Cloud Advocate at Microsoft, focusing on applied AI. In this session we're going to cover what machine learning is and the ways we can implement this in IoT scenarios. We're going to create a classifier using the custom vision service and run that classifier in an IoT Edge solution. We will begin with an introduction scenario, which we'll use as a reference throughout this presentation. In our world today, there are many different creatures that are on a mission to make our lives miserable. I believe every country will have their own little enemies. But in America, there is this big problem with raccoons mashing up the trash in the streets. I think we can all sympathize with the American nation that this is a real problem. One day, Carissa thought, enough is enough. Raccoons, no more trashing my garbage. And she started building a Trash Panda defense system, so she could sleep again at night. She started drawing and came up with the following design. When the camera detects the raccoon on the trash, the alarm should go off, scaring away the raccoon. So she went to the store and bought a Raspberry Pi, a camera, a lamp, because she didn't want to make noise for the neighbors, and she got an Azure subscription. Now that she bought all the components, she had to start thinking about how to build this solution. To solve this problem with the camera, she needs to build something that can look at an image and detects if there is a raccoon in the image or not. And this is a problem that is hard to solve with traditional programming, but fairly easy with machine learning. First, it is important to understand what machine learning actually is. The most common definition is that it is giving your computer the ability to learn without explicitly programming it. When I'm programming, I would write an algorithm, run data through that algorithm, and get an answer. But with machine learning this is switched. Instead of creating the algorithm, I let the computer create this algorithm for me by providing it data with answers as input. In machine learning world, the algorithm is called a model. And what we can do now is, we can run new data through this model and get a prediction about the input. For our Trash Panda defense system, we would have to create a classification model. You can see this as a function that looks at an incoming video frame and gives a prediction back if there is a raccoon on the image. And to create this model, we need three things. We need a lot of images with raccoons on it. We have to select a training algorithm, and we need an environment where we can run this training algorithm. These three things will deliver us a model that we can later use in our Trash Panda defense system. But what if suddenly unicorns become a problem? If that would be the case, she would need to retrain a model so it can also recognize unicorns. And this is done by adding images of unicorns to the dataset and train the model again. Now that we understand what we have to create, let's have a look which tools are available on Azure. First, there are the domain-specific pre-trained models. These models are created, run, and maintained by Microsoft, and exposed to you through an API in Azure. The only thing you have to do to access these models would be go into the Azure portal and create the one you like. There are around 40 different models available, divided in 4 main areas. There is vision, to make your application see the world. There is speech, to make your application talk and listen to you. Language, to understand what is being spoken. And knowledge, to give your application a brain. But if you dive deeper and you want to create your own models, you can bring your own tools and frameworks and use services like Azure Machine Learning, or create a machine learning virtual machine to boost your productivity. And last but not least, there is a lot of powerful compute available that makes the training of your model fast and reliable. To create our raccoon classification model, there are a few options available. We could use the Computer Vision API. This is an API that is pre-trained on a large dataset and can classify most common objects. A really nice bonus is that it can generate a description of what it sees on the image and tells you where the found objects are. Besides detecting objects, it also has an OCR function. It can read handwriting and detect celebrities on the image. This is a very easy way to get started with vision. But not all objects are detected with the Computer Vision API, and sometimes you just want to create something that can just detect that specific object. Like in our case, we want to be able to detect raccoons and unicorns. For this scenario you can use the Custom Vision service. This is a service that helps you easily build models that can perceive particular objects. This service comes with a user-friendly interface that walks you through developing and deploying custom computer vision models. Then either use the API to quickly predict images or export the model to a device to run real-time image understanding. if you want to control the complete lifecycle of your model, you can use Azure Machine Learning. This service helps you accelerate the end-to-end machine learning lifecycle and empowers developers and data scientists with a wide range of productive experiences for building, training, and deploying machine learning models faster, and accelerates your time to market and enables team collaboration with industry-leading MLOps, DevOps for machine learning. The platform is secure and designed for responsible ML. To use the Custom Vision service, you will need to create a Custom Vision training and prediction resource in Azure. Create a new resource. Select AI and Machine Learning and select Custom Vision. Click Create. We want to create both the training resource. This is the resource that will train the model, and we want to have the prediction endpoint. We don't need the prediction endpoint for the Trash Panda defense system, but in this demo I want to show you how to use this. Select a resource group. Give your resource a name. Select for both endpoints the location closest to you. We are now choosing for the S0 tier, but you can try it out for free using the free tier. Click Review and click Create. You can also create these resources through the Azure CLI or by using ARM templates. Let's open the Custom Vision portal. Here we can create a model through a visual interface. Everything you see in this demo can also be done by using the API or with one of our SDKs. To create your project, select New Project. Enter a name and a description for the project, then select a resource group. If your signed-in account is associated with an Azure account, the resource group drop-down will display all of your Azure resource groups that include a Custom Vision Service resource. Select Classification under Project Types. Then under Classification Types, choose Multi-Class. Multi-label classification applies any number of your tags to an image, 0 or more, when multi-class classification sorts images into single categories. Every image you submit will be sorted into the most likely tag. You'll be able to change the classification type later if you want to. Next, select one of the available domains. Each domain optimizes the classifier for a specific type of images. You can change the domain later if you wish. General. Optimized for a broad range of image classification tasks. If none of the other domains are appropriate, or if you're unsure of which domain to choose, select a generic domain. Food. Optimized for photographs of dishes, as you would see them on a restaurant menu. If you want to classify photographs of individual fruit or vegetables, use this domain. Landmarks. Optimized for recognizable landmarks, both natural and artificial. This domain works best when a landmark is clearly visible in the photo. This domain works even if the landmark is slightly obstructed by people in front of it. Retail. Optimized for images that are found in a shopping catalog or shopping website. If you want high precision classifying between dresses, pants and shirts, use this domain. Then finally, there are compact domains. These domains are optimized for real-time classification on mobile devices. The model generated by compact domains can be exported to run locally. Because we are going to run this model on a Raspberry Pi, we are going to choose General Compact. Click Create Project. Now we have to choose our training images. As a minimum, it is recommended you use at least 30 images per tag in the initial training set. You also want to collect a few extra images to test your model once it is trained. In order to train your model effectively, use images with visual variety. Select images that can vary by camera angle, lighting, background and visual style. I took out Bit, our trash panda, for a photo shoot and got photos from different angles with different backgrounds. Click the Add Images button and then browse local files. Select Open, to move to tagging. Your tag selection will be applied to the entire group of images you have selected to upload, so it is easier to upload images in separate groups according to their desired tags. You can change the tags for individual images after they have been uploaded. Our classifier is going to have two tags, bit or not bit. So I've created a group of images that not contain bit, but other objects like a can or a robot. I also add these images and tag them with a negative tag. To train the classifier, select the Train button. The classifier uses all the current images to create a model that identifies the visual quality of each tag. After the training is completed, the model's performance is estimated and displayed. The Custom Vision service uses the images that you've submitted for training to calculate precision and recall, using a process called k-fold cross-validation. Precision and recall are two different measurements of the effectiveness of your classifier. Precision. This indicates the fraction of identified classifications that were correct. For example, if the model identified 100 images as bit and 99 of them were actually bit, then the precision would be 99%. Recall indicates the fraction of actual classifications that were correctly identified. For example, if there were actually 100 images of bit and the model identified 80 images as bit, the recall would be 80%. The probability slider on the left pane of the Performance tab. This is the level of confidence that a prediction needs to have in order to be considered correct, for the purpose of calculating precision and recall. Now that we have finished training the model, we can test it to see if it can recognize bit, our trash panda, on images that the model has never seen. Custom Vision offers an easy interface to do this. In the top right, you'll find a Quick Test button. When you click on this, you can test the model. You have two options here. Provide an image URL in the URL field. And if you want to use a local stored image instead, click the Browse Local Files button and select an image file. The image you select appears in the middle of the page. Then the result appears below in the image in the form of a table with two columns, labeled text and confidence. The images you send to your model can be used to retrain your model. You can find those images under the tab Predictions. Here you see the same images as used for the test. To add an image to your training data, select the image, select the tag, and then select Save and Close. The image is removed from Predictions and added to the training images. You can view it by selecting the Training Images tab. You can click Train again to retrain your model with the new images. Before we continue with the demo, let's talk a little bit about how we can improve a classifier. The quality of our classifier depends on the amount, quality and variety of the labeled data we provided, and how balanced the overall dataset is. A good classifier has a balanced training dataset that is representative of what will be submitted to the classifier. The process of building such a classifier is iterative. It is common to take a few training rounds to reach the expected results. A general pattern that will help you build a more accurate classifier is first, a general training round. We add more images and balance the data, we retrain. Then we add again some more images, with varying backgrounds, lighting, object size, camera angle and style, and we retrain it again. 4. We use new images to test predictions, and then we can modify existing training data according to those prediction results. So one thing we want is to prevent overfitting. Sometimes a classifier will learn to make predictions based on things images have in common. For example, if you're creating a classifier for apples via citrus and you have used images of apples in hands, and citruses on white plates, the classifier may give an undue importance to hens vs plates, rather than apples vs citrus. To prevent this from happening, use the following guidance. Data quantity. The number of training images is the most important factor. We recommend using at least 30 images per label as a starting point. With fewer images, there is a higher risk of overfitting, and while your performance numbers may suggest good quality, your model may struggle with real-world data. Also important to consider is the data balance. For instance, using 500 images for one label and 50 for the other one makes an imbalanced training dataset. This will cause the model to be more accurate in predicting one label than the other. This will cause the model to be more accurate in predicting one label than the other. You're likely to see better results if you maintain at least a 1:2 ratio between the label with the fewest images and the label with the most images. For example, if your label with the most images has 500 images, the label with the least images should have at least 250 images for training. Let's talk about data variety. Be sure to use images that are representative of what will be submitted to the classifier during normal use. Include a variety of images to ensure that your classifier can generalize well. Let's look at a few things that can make your dataset more diverse. Backgrounds. Provide images of your objects in front of different backgrounds. Photos in natural backgrounds are better than photos in front of neutral backgrounds, as they provide more information for the classifier. Lighting. Provide images with a variety in lighting, especially if your images used for prediction have different lighting settings. It is also helpful to use images with a variety of saturation, hue and brightness. Object size. Provide images in which the objects vary in size and number. For example, a photo of a bunch of bananas and a close-up of a single banana. Different sizing helps the classifier generalize better. Camera angle. Provide images with different camera angles. Style. Provide images of different styles of the same class. For example, different variety of the same fruit. However, if you have objects of drastically different styles, we recommend you label them as separate classes to better represent their distinct features. Back to the demo. Let's add some more diverse images of our Trash Panda bit to our training dataset. We go to Training Images and click Add Images. Select 60 more images with bit on it and select 60 more with not bit on it. You might have noticed that I didn't tag my new images. So these images can now be found under Untagged Images. We're going to use our model we have just trained to tag these images for us. Click on Suggested Tags and click Get Started. It can take a few minutes before it has tagged all the images. When the tagging is done, click on the tag, take a look if the tags are correct, and click Confirm Tags. Now these images are added to our training dataset, and we can click on Train to retrain our model. For our Trash Panda defense system, we are going to export the model. You can export every iteration of your model. To export your model, go to the Performance tab and click on the iteration you want to export. In the top you can click Export. Here you can choose for a TensorFlow model, which will run on Android, a Core ML model for iOS 11, and Onyx for Windows ML. You can also get a Docker container for Windows, Linux or ARM architecture. The container includes a TensorFlow model and code to self-host a custom vision API. Another way of using your model is to submit images to the prediction API. You will first need to publish your iteration for prediction, which can be done by selecting Publish and specify a name for the published iteration. This will make your model accessible to the prediction API of your Custom Vision Azure resource. When you have published your iteration, you can look up the details and start submitting images to the endpoint. Let's start Postman and submit an image to the endpoint and take a look at the response that the API sends back. Copy the URL and the prediction key. And select the image we want to classify. When we look at the JSON, we see that the model running in our prediction endpoint has classified the image as an image containing bit. In this demo we have seen how to create a custom vision training and prediction endpoint in the Azure portal, seen how we can upload images, tag them and train a model. We learned what the different metrics mean, like precision and recall. We talked about how you can improve your model and prevent overfitting. Retrained our model by adding more diverse images and used the first iteration of our model to auto-tag the images. And took a look at how we can export the model so we can use it in a mobile app and in our Trash Panda defense system. We also learned how we can publish the model to our prediction endpoint and use it as an API. Now that we have created our raccoon classification model, it is time to find out how we can implement this model in our Trash Panda defense system. First, let's zoom out and look at what we have to create. We would have this thing that generates data. That would be the camera that generates frames. Then we need to analyze the data. That would be running the frames through the model. And finally, we have to take an action. In our example, it would be turning the lamp on or off. And there are multiple ways of doing this, and we're going to zoom into two of these scenarios. The first scenario would be generating the data on the IoT device, analyze the data in the cloud, and take the action on the device. In our case, the Trash Panda defense system would send every frame to the cloud, run the frame through the model, and send the prediction back, and the device would turn the lamp on or off. This scenario enables us to quickly tune the model in the cloud, but it takes a long time before the lamp is turned on or off, and sending all the frames to the cloud requires a fast internet connection. Another approach would be running the model on the device itself. A common misconception is that you would need a very powerful computer to run a model, but for simple models like this, you can run it on a Raspberry Pi. However, training the model is very compute heavy and cannot be done on a Raspberry Pi and is highly recommended to do in the cloud. In this scenario, the video frames are not leaving the device and are processed locally, meaning the device could even function without a connection to the internet and act without any delay on the outcome of the model. We could even add something that would only send the output of the model to the cloud, so we can create a Trash Panda defense system control center. Both of these approaches have their own pros and cons. Let's have a look at a few of them. If you look at IoT in the cloud, it is really good if you don't need a real-time action being performed on the device itself, like for instance remote monitoring and management. Also in the cloud, you have access to infinite compute and storage to train compute-intensive AI models. The biggest advantage of running IoT on the edge is, next to the low latency for real-time response, is that you can pre-process the data on the device itself, meaning that the video feed from your camera or any other data generated by the device never have to leave the device. And this is a good thing if you have heavy security and privacy requirements. The best scenario for our Trash Panda defense system is that we are going to build, test and manage our solution in the cloud and deploy the solution to our Raspberry Pi device to run locally. This will give us the flexibility and power of the cloud to train the model, the low latency of running the model on the device to scare the raccoon away fast, because everything is processed locally on the device. It is not taking up any bandwidth, and the device could even be placed in a location where there is no internet available. Now that we have defined our application strategy, we can start building and deploying it. To build and deploy it, we're going to take a look at Azure IoT Edge. Azure IoT Edge is a fully managed service built on Azure IoT Hub. This service enables you to deploy your cloud workloads to run on an Internet of Things edge device via standard containers. It works with Linux and Windows devices that support container engines. The runtime is free and open source under the MIT license. IoT Edge runs Docker-compatible containers. In these containers you can run your own business logic. And through the cloud interface you can manage and deploy the workloads to the device. IoT Edge uses modules. For our Trash Panda defense system we would need 3 modules. A camera module that is taking care of the connection with the camera and extracts the frames from the camera feed. An AI module. In this module we would run our machine learning model that has been trained in the cloud. And last, a module that will handle the alarm. Every module is a separate Docker container that is stored in an Azure Container Registry. To deploy this module to the edge device, we need to create a deployment manifest. In this file we specify where the modules are located and how they should communicate with each other. Via IoT Hub, we can deploy this manifest to our connected devices. When the deployment is done, the modules run and communicate locally on the IoT Edge device. Let's zoom in a little bit deeper and take a look at what is running on the IoT Edge device. On the device, the IoT Edge runtime is installed. By default, this comes with 2 modules. The Edge agent that takes care of the modules and deployment, and Edge Hub, a local IoT hub that enables our modules to communicate with each other. We have our 3 modules that were installed through the IoT Edge deployment manifest. The camera module connects the camera and sends the frames to the custom AI module. The custom AI module puts the model score on the local IoT Edge hub. The alarm module receives the module score from the Edge hub. In the alarm module, if the model score reaches a certain threshold, the lamp is put on and a notification is put back on the Edge hub, which is sent to the IoT hub in Azure for monitoring purposes. Now that we know what to build, let's actually implement a model we have created using custom vision in an IoT Edge solution and deploy it to this Raspberry Pi device. Here you see a Raspberry Pi 4 with the latest Raspbian installed. It is connected to the power, and I have connected it to the Wi-Fi and enabled SSH, so I can connect to it from my computer. I also connected a USB camera and connected some LEDs to the GPIO pins on the Raspberry board. To get started, we first have to set up 2 things in Azure. We need to create an IoT hub and an Azure Container instance. To create the IoT hub, go to the Azure portal and create a new resource. Go to the Internet of Things and select IoT hub. Select your subscription ID. Create a new resource group. Select the region closest to you and give your hub a name. Click Review and create. Next, we need to create an Azure Container Registry. In this registry we're going to store our IoT Edge modules. To create the Azure Container Registry, go to Containers, click on Container Registry. You can deploy it in the same resource group as the IoT Hub. Give it a name, select the right region, and the standard SKU is enough for what we are going to do. Click Review and Create. When the registry is created, we have to enable login with the username and password. Open the resource and click Access Keys. Enable here Admin User. The first step is now completed. We have created an IoT Hub and an Azure Container Registry. We have done this now by using the Azure portal, but you can also create these resources using the Azure CLI or by creating an ARM template which you can run from Azure DevOps. Now that we have our resources set up in Azure, it is time to connect the Raspberry Pi to the IoT Hub. To do this, connect to your device over SSH. The Azure IoT Edge runtime is what turns a device into an IoT Edge device. First, we need to register a Microsoft key and a software repository feed. Copy the generated list and install the public key. Next, we need to install a container runtime. Azure IoT Edge relies on an OCI-compatible container runtime. For production scenarios, we recommend that you use the Moby-based engine. The Moby engine is the only container engine officially supported with Azure IoT Edge. Docker container images are compatible with the Moby runtime. First, we need to update our package list. Install the Moby engine. Install the Moby command line interface. The CLI is useful for development, but optional for production deployments. Now we can install the Azure IoT Edge Security Daemon. The IoT Edge Security Daemon provides and maintains security standards on the IoT Edge device. The daemon starts on every boot and bootstraps the device by starting the rest of the IoT Edge runtime. We first update the package list on our device. We check to see which versions of IoT Edge are available and install the most recent version of the security daemon. The final thing we need to do on the device is to add the connection string to the configuration file. To get the connection string, we have to go back to the Azure portal and open our IoT Hub. We navigate in the left menu to the section Automatic Device Management and open IoT Edge. Here we click on Add an IoT Edge device. We give it a name and click Save. Click on the device and copy the primary or secondary connection string. Go back to the device to configure the security daemon. The daemon can be configured using the configuration file at /etc IoT-edge config.yaml. The file is write protected by default. You might need elevated permissions to edit it. Open the configuration file. Find the provisioning configurations of the file and uncomment the manual provisioning configurations section. Update the value of device connection string with the connection string from the IoT Edge device. Make sure any other provisioning sections are commented out. After entering the provisioning information in the configuration file, restart the daemon. All the infrastructure is now ready to run our Trash Panda Defense System modules. I've already created all the modules, so let's clone the repository and take a look what is inside. In this repository are a few important files. First, there is the deployment.template.json. A deployment manifest is a JSON document that describes which modules to deploy and how the data flows between the modules. There is a folder called modules. In this folder our 3 modules are located. The camera capture module takes care of the camera. Image classifier service is running the machine learning model. And simple LED turns the LED on and off. Let's take a look at the simple LED module. Every module has a Docker file. This file contains the configuration of the container, like which base image to use and which packages to install. Then, there is the module JSON. This file holds the IoT Edge module configuration. In this file we see variables like the container registry address. If you build the IoT Edge solution, this is the registry where it will store your containers. These variables we can set in the .env file, and we can retrieve these details from the container registry through the portal. Let's open the Azure portal and navigate to the container registry. Click on Access Keys and copy the login server, the username and the password. We are almost ready to build the solution, but first we need to get the model we have trained from the custom vision service. Let's open our project and go to the tab Performance. There we click on Export. We choose here for the Docker file and choose for the ARM Raspberry Pi file. Click Download. Open the zip file and copy the labels and model file to the image classifier app directory. We also need to install the IoT Edge extension in Visual Studio Code. You can find this extension under the menu item Extensions and search for IoT Edge. When you have installed this extension, you should see Azure IoT Hub in the bottom in the Explorer. Here you can connect Visual Studio Code to your IoT Hub and view your devices. Click on the 3 dots and choose Select IoT Hub to connect. Because we have the IoT Edge extension installed, we can do a right-click on the deployment template and click Build and Push IoT Edge Solution. This command will build the Docker containers for the modules and will push them to our repository. This can take a while. When all the containers are built and pushed, we can go to the ACR and view the repositories there. To deploy these modules to our IoT Edge device, we have to generate an IoT Edge deployment manifest. This can be done by right-clicking on the deployment template and select Generate Deployment Manifest. The deployment manifest will appear in the config folder. To deploy this manifest, you can right-click on the manifest and select Create Deployment for Single Device. In the top of Visual Studio Code, you can select your IoT Edge device now. Select the device and wait for the deployment to finish. There are a few ways how you can view if the deployment is successful. In Visual Studio Code, we can use the extension to see which modules are running on the device. Or we can see it on the device itself by using the IoT Edge command line command IoT Edge list. Here you can see all our modules are up and running. Now it is time to see it in action. Let's release Trash Panda Bit to the stage and see if we can scare him away with our LED lights. That worked! No more trash pandas messing up my trash. This is the end of the IoT Edge demo. In this demo we have seen how to create an Azure IoT Hub and Azure Container Registry in Azure, how to install IoT Edge on an Edge device, learned about the project structure of an IoT Edge solution, built the IoT Edge solution and created a deployment manifest, deployed the solution to a single IoT Edge device, and saw that the lights scared away our Trash Panda bit. In this session you got a peek in how you can use Azure IoT Edge and Azure AI to create a Trash Panda defense system. We covered what machine learning is and which tools there are available in Azure. We talked about the difference between IoT in the cloud and IoT on the edge, and showed you how to use Azure IoT Edge to manage your solution. For links to the relevant documentation, resources, demos used in this presentation, and a follow-up presentation, check out ak.ms/iot30/resources. If you're interested in using this presentation and/or this video recording for an event of your own, the materials can be found on GitHub at akms/iot30. If you enjoyed this presentation and are interested in other topics covered in the IoT Learning Path, you can find them all at ak.ms/iotlp. We have covered quite a few topics in this session, and would like to share that we have curated a collection of modules on the Microsoft Learn platform, which pertain to the topics in this session. This will allow you to interactively learn how to build intelligent edge applications and how to manage them using Azure IoT Edge. There are also many modules on how to build AI models, using tools like Azure Custom Vision and Azure Machine Learning. This presentation and the associated Learn modules can help guide you on a path to official certification. If you're interested in obtaining accreditation that can help you stand as a certified Microsoft Azure IoT developer, we recommend checking out the AZ220 certification. You can find details on the topics covered and schedule an exam today at ak.ms/iot30/certification. For more interactive learning content, check out Microsoft Learn at microsoft.com/learn to begin your own custom learning path with resources on the latest topics and trends in technology. Thank you again for attending this session.
Thank you, Hank, for those helpful insights. We have come to the tail end of our program, but the question is, what's next after all of these? To wrap up the program is a discussion about profiting from enterprise services with private LTE, 5G, and IoT by Affirmed Networks Vice President and Chief Product Officer, Ashwin Moranganti.
Hi, my name is Ashwin Moranganti. I'm the Chief Product Officer at Affirmed Networks, a Microsoft company. We've always been hearing about all the big opportunity with 5G and all of the enterprise opportunities and the new ways the network are going to be built. And this is all about the digital transformation of the operators or the mobile networks. There are several other sections that we have been recording. Some of them talk about how we build the networks, about the cloud native technologies that we are coming up with, the automation that we are bringing to the operators. But today's session, we're going to focus on the enterprise opportunities. What are the enterprise opportunities? What can the operators offer to the enterprise? And what do Affirmed and Microsoft bring to the table? Okay. So let's get down directly to the 4 opportunities that I want to talk about. The first one is what we call is network edge compute. The second is edge extension. The third is private networks. And the fourth one is slice as a service. I'll go deep into each section one by one. And we'll talk about, what it does mean to the enterprise, what can the operator offer, and what does Affirmed and Microsoft bring to the table. So the first one is the network edge compute. There are a lot of emerging applications which require to be running much closer to the edge of the customer. And these require either low latencies or bandwidth efficiencies. And they need to be running much closer to the network. Today, most of the traffic will go down from your mobile phones, goes to the RAN, goes to the mobile core, and then goes to the internet, and then goes to most of the applications are running on the cloud somewhere. And that's how the traffic flow is. What we want is these applications to be somehow to be running closer to the actual activity. And so that means that there needs to be a compute requirement much closer to the network. And that is what is the edge compute opportunity. If you look at where the edge is, and the edge is essentially, I'm showing you a picture wherein on one side you will have the public cloud or the regional mobile operator data center, and that is where most of the applications run today. And you typically get around 50 milliseconds of latency, and that's okay for a lot of applications. But there are a lot of emerging applications which will require a little bit lesser, which is like in the 10 to 35 milliseconds acceptable latency. And that is what we call is the edge compute at the mobile network operators aggregation center. So that is where is one of the edge network location that we are going to talk about today. And then further along, where if you require even more lesser latency, like less than 5 milliseconds, and that's going to be at the premise itself or at the tower or at the venue, and that is going to be the other location for the edge compute. So let's look at an example application like immersive gaming. Everybody has a console today at their homes. And what if you wanted to play the same games that you've been playing on the console, but you wanted to do it on your mobile phone so that you go to your vacation homes, you still can continue to access all your gaming, but not without the console. That means whatever is running on the console needs to be running somewhere on the network. And that will be a perfect location for an edge compute or edge network. As everybody knows, the mobile gaming on the soft smartphones generates about $68.5 billion, and it's going to be continuously growing. And so could be a great application which both the operators could be offering as a value added to the mobile phone subscription, and the gaming servers could be actually be located on the operator network so that the mobile traffic coming from the phones directly comes as soon as it enters the operator network at the edge of the network. It is peeled off and led to the gaming servers there. This has an amazing benefit, both as both a revenue opportunity, a best subscriber customer experience, and this is the first application that we are talking about, the network edge compute. So, in summary, the mobile operators can deploy an Azure Edge Zone alongside the mobile core user plane at the edge of the network, and the mobile traffic that is carrying the edge workloads will be offloaded to the edge at the edge Azure Edge Zone. The operator provides the space and power. Azure shares revenue with the operator. The service could be co-branded, co-sold, and many other ways. And the same Azure Edge Zone can also run actually network workloads if the operator chooses to. If you go to the next picture, which shows what we are talking about, is go to any operator who has deployed a CUPS mobile core. In this case, we are showing the affirmed mobile core, which is actually deployed in many other operators' networks. And at the same place, all you have to do is deploy an Azure Edge Zone with the carrier, and that will be hosting a lot of the edge applications. As soon as the traffic is determined that it needs to be broken out, and it is sent to the Azure Edge Zone with the carrier, and the applications are going to be running there. So all of the edge application orchestration and everything is already done, and it's going to be done from the Azure public. And this would be the first application that we wanted to introduce as an opportunity towards gaining new enterprise revenue. And by deploying an Azure Edge Zone along with an affirmed mobile core user plane, this is one of the first services. The next one that we're going to go to is the edge extension. Let's talk about a use case like an in-stadium instant replay. The users already have their mobile phones, but the stadium experience of the stadium owners wanted to stitch multiple videos from the fan's phone and wanted to create an immersive experience. That experience is an application, And an application could be running as close to in the stadium premise itself, and so that all the videos that are generated from the fans are sent out, and instead of going back to the mobile network core and the public clouds, it would actually be peeled off right there and broken out, and the immersive application is created, and that is what is being viewed for the fans. This is an example where you would want an edge compute, a mobile application breakout at the premise at the actual event. The second one is, quite similar. As you can now see in this world of COVID, automation is big. IoT for automation is going to be even more at a scale that we have never imagined. And a lot of these applications and optimizations for maintenance predictions, making them smarter, making the manufacturing operations more seamless, you would want a faster, rapid processing, decision making at the edge of the network. Again, all you would need is the sensors, and all of these equipment which are connected with the wireless can be again broken out at the premise itself, the traffic, and fed to these rapid processing applications and decision making applications which are running at the edge of the network and can be fed and can be addressed. Another example is the first responders, public safety kind of applications, wherein technologies like facial recognition, all of these things need to be again running closer to where the action is happening. Instead of the video being sent to the public clouds or sent to the applications which are running in centralized data centers, could actually be using inference technologies at the edge and could be providing these kinds of services. So these are just examples of some of the reasons why an operator needs to extend his mobile network to the edge of the network, and that is where the applications need to be broken out. So let's talk about carrier edge extension. With Affirm's CUPS technology, operators today are deploying virtualized technology in their networks. The user plane and the control plane of the mobile network are separated, and the operator can actually extend the same user plane onto the customer premise. In this time, what the operators can do is they can deploy an Azure private edge zone, which can host both the carrier's user plane and can also host the edge applications like that immersive stadium experience that I just talked about, right? And by doing that, the operator is actually just extending his technology, but does not have the operational difficulties of deploying on the edge and managing these boxes on the edge. It all could be done and provided by the Azure service. So if you go to the pictorial slide here, the operator has been deploying a mobile core again, and that is what is deployed today, and he's deployed CUPS. With Affirmed, we can deploy that mobile core user plane that you see in the picture there, which could be running on the Azure private edge. And the private edge and the edge applications and the network function can all be orchestrated from the Azure public. So the benefits are huge to the operator. The operator can simply add a new service to his full catalog, and the applications like the manufacturing, the stadium experiences, they can simply deliver amazing customer experiences with that. So let's move on to the next one. And the next one is what is widely becoming the most popular one. It's called the private networks. So let's look at why private networks. As you can see, and we talked about, manufacturing is a sector which is going to be one of the primary focus areas for us. Azure IoT is one of the leading solutions out there, and we want to extend our leadership in that area combined with the network too. It is going to be providing amazing results. So let's look at the manufacturing. With the automation that is going around, there are robots coming in the factories, and these robots are connected with cameras that are sensing all the things that are happening on there. And these are HD cameras. A lot of video is going to be digested and ingested, and that is going to be fed to smart applications which are running on the edge to provide guidance to the operators there. This could be again safety, asset management, and all of these things. So one of the important ones is like the immersive training, remote assistance, where people are getting the assistance remotely and they're able to do the diagnostics much better by watching the video on the one side with the halo lenses and be able to repair things with a lot of guidance. This kind of factory automation and oil and mine, natural public venues, everywhere there is a demand for networks which are private. They have their own RANs, they have their own small cell, and they have full control of the network because these are actually more critical than just a consumer phone. So for the reliability, for the security, for the throughput, the amount of bandwidth that they were consuming, for low latency, they are looking to private networks. First, the market will adopt a lot of the cases where Wi-Fi is not adequate, and then eventually it's going to be also be a Wi-Fi alternative. What do mobile operators can do today? Mobile operators do have the technology, but this technology has to be simplified, automated, and so that they are able to do million sites at ease. Today, a lot of it is done centrally, and now when you distribute it, you need the automation that is necessary in order to be able to go ahead and deploy at a large scale, manage, independently monitor. So the operators have a great opportunity. And unlike Wi-Fi, it still requires an operator's skill set. RF design is not as simple as just deploying a Wi-Fi access points. So enterprises are looking for carriers to be able to provide this managed service and get their private networks. And the operators can also have one of the biggest revenue opportunities right now. So if you go to what does Affirmed and Microsoft bringing in, so the mobile core technology again was available, has been deployed. We used to call it network in a box and deployed at many locations today. This is not a new kind of a service, but what we are bringing to the table is that the original versions had a lot of manual intervention. The deployments were taking a long time. The deployments would have a lot of professional services involved there. But now what we want to be doing is you ship an Azure Private Edge Zone connected to the network. And right from your console, just from the Azure public portal, you're able to activate that public edge zone and you're able to deploy, orchestrate all of any edge applications that are in the marketplace. And in addition to that, you're going to be able to partner with the operators who are going to be offering their managed service, and that could be a private network service. And that private network service can be orchestrated by the Azure portal to be able to be deployed on the private edge zone. This way, the only manual part is shipping the server and connecting to the internet and doing the RF design. But other than that, he's able to do all of this remotely. All aspects of orchestration, lifecycle management, monitoring, and SLAs are all being able to do it from the portal. This will provide the scalability that is necessary, the ease that is necessary to be able to do millions of sites. Apparently, there are about 14 million sites which have a demand for private networks. And if each site is providing X amount of dollars per month, you can imagine what the revenue potential is going to be. So not only this, if you go to the next picture that we are showing here, we are also combining with the operator assets. We can deal with scenarios wherein factories or manufacturing sites have multiple locations. And those locations, people, the devices, or they are going from one location to the other. You still want some sort of a simplified subscriber and policy management. Instead of having per site subscriber and policy, you would be able to do that. So we are able to accommodate and provide that kind of a service. Integrating with the operator's existing code, we're also be able to provide with roaming services. So while the devices are in the factory side, they're using the private networks, but when they roam onto the macro networks, there also the service still continues, and then they go to the next site, the service also continues. These are some of the services and innovation that Affirmed and Azure are bringing to the operator in order to provide an amazing experience for the private networks deployments for the enterprises. Now that brings us to the last of the four services, what we call is slice as a service. And what we are talking about is really a vertically focused mobile core as a service. Everything that I've been talking about is not new. The technology like 4G and 5G is new, but nevertheless, the operators have been doing it. What we are bringing to the table is automation, the speed and agility for the operators, and this is what we call it the digital transformation. So let's look at the mobile core overlays. The operators have been deploying cores which are dedicated to IoTs, dedicated to, let's say, the automobile sector. But the deployments today are silos, and they deploy the entire hardware, the virtualization infrastructure, they do the mobile core, and it's essentially a silo. And the reason it needs to be a silo because they need to be independently monitored and independently managed. So how do you make that even better? When you're making such an investment, you need to validate the business cases and then, start to build these silos. What if it was a little bit more easier? What if it was a lesser investment and you are able to just try out and instantiate with just software, just another core and go after new businesses, let's say drones, and just a core mobile core dedicated to drones across the country and independently managed and monitored. And you wanted to just try it. Maybe the business case is not 100% solid. What if there was a risk-free innovation opportunity wherein you would just go to any other digital transformation which is happening in the other enterprises? They would go to the public cloud. They will be able to instantiate a mobile core and try the drone service, manage, manipulate, and grow that business. And if things don't work out, you could shut it down. That kind of agility is what we want to, bring to the operators. The other important point is some of these things may take up a lot of bandwidth, a lot of servers. Some may require lesser bandwidth and lesser servers. But by bringing the cloud economics to the table, you are able to accommodate the various bandwidth needs, the server needs, the compute needs of these cores, and still be able to bring the monetary benefits to the operator. So the mobile operators, what we want is a full turnkey service from Affirmed and Azure, wherein we can provide a mobile core. The operator still owns the RAN, the customer, the brand, the ideation, all of that. All we're trying to do is the ability to instantiate a core, connect to their RAN, and then the operators offer a vertically focused MVNO service. So if you go to what was network slicing, it was all about the standards have done a lot more work. They knew about this business opportunity and they created a lot of standardization in slice management. There are several 3GPP technologies like NSSMF and NFMF. And the main goal was one size doesn't fit all. We need to be able to create multiple slices which are independently instantiated, managed, and monitored, and the ability to let them grow independently to whatever scale that they can. And that's what we want to bring. So it's a combination of the cloud technology and the 3GPP innovations that have been done. We're putting that together along with the mobile core technology that we have, offering it in a form to energize the operator offerings. So what is Slice as a service? Slice as a service will allow the operators to disrupt the economics of innovation. And by rapidly ideating in new service slices on the cloud with very little cost, they are able to meet the diversity of requirements. Either they are latency sensitive, throughput sensitive, either for security, either for high availability, whatever may be the reason. But you will be able to do that with the most optimized cost. And all of these slices are going to be differentiated services. And this is like a pipe that addresses all the needs, but it's actually going to be one of the most intelligent connectivity options that the operator will provide, and which is going to increase the brand of the operator and with the automation that we are bringing to the table. So if you look at the next pictorial that we have, the operator starts off with deploying an Azure Edge with the carrier. Will be able to offer network compute or edge compute applications and bring in more revenue. he can use the same edge infrastructure which is deployed in the operator's network and run the 5G network functions. And that's what you will see in this picture as 5G user plane running there. You can extend the 5G user plane onto the customer prem by running an Azure private edge, and the user plane is running on the private edge. That is the carrier edge extension. And then you could also be deploying fully standalone private networks on Azure Private Edge Zone, wherein the entire mobile core with its own RAN and everything is deployed in those locations. By connecting all of these things and a control plane which is going to be running on the Azure public, you'll be able to provide all the four services that we talked about, very seamlessly. And that's the summary of the presentation here. We have talked about the four big opportunities for the operators. These are actually already deployed use cases that we have shown. May not be 5G, but with 4G. And what's coming in the near future. The automation and the cloud economics that Affirmed and Azure are bringing to the operator. What I wanted to do was take a moment and give a preview of one of the offers. Here's a private LTE demo that we're going to do. Microsoft has been putting together an ecosystem and to offer a private LTE service or a private 5G service. And private networks are not new. I mean, mobile operators have been doing that for several years. But what the opportunity right now is really the massive scale and the amount of sites, the opportunities that are coming to the service providers. So they would want a lot of automation, and that is the key. How fast can you deploy? And with remote deployment of thousands of these networks, how do you manage them? How do you make sure that there is no truck rolls necessary in order to diagnose some problems or upgrade some things or manage any issues? So it's all about automation. And so with this Affirm technology in conjunction with the Microsoft technology is what is the automation that we are going to demo here. So imagine that a service, an enterprise customer has already got an Azure private edge zone, and he's got that from the marketplace, and he's be able to run enterprise applications on that platform. The enterprise applications could be something like an IoT gateway or any AI ML reference applications. Enterprise sees a need for a private network, and he goes to and buys an MSP offer. MSP is the operator, a managed service provider, either from the managed service provider's website or his promotions or from the Azure's marketplace. Once you do that, the MSP is going to be going to the Azure portal and is going to be able to instantiate a private network service. And he will use the Affirm Service Manager to deploy onto the Azure Private Edge Zone. And he will be able to do all the operations from the portal and should be able to do monitoring and get the private networks up and running. So let's go through that sequence here. If you start off, assume right now that the enterprise has reached out to the operator, and the operator goes to the Azure portal right now. And from here, he's going to start this Azure Network Function Manager, and he's going to create a network 2, and he's going to create this device. It happens, and he uses an Affirm packet core. It could be any of those packet cores. Azure has been pretty open to support other vendors' solutions also. And then we go ahead and review this instantiation of this virtual network function. It contains all of the MME, P gateway, HSS. And once the virtual instance is created, what you'll be able to see is a small service key is actually going to be generated on the Azure portal. The service key is on the second column there. And once you pick it up, you will go to the service manager. And you can add all your enterprises and multiple sites, and go ahead and we'll add a network 2 here, and basically just a site and the service key which you just created. This is what is linking the virtual network function, which is the entire private network mobile core, to this private edge box or private edge cloud, and you are able to go ahead and provision that. And once you click on that, and right now the VNF state is unknown and it's not provisioned yet. This is a sample of all of the provisioning details. We have an automated version, but I just want to show that a lot of flexibility is there to be able to configure these things. And I just don't want to say that it's just click, click, and you feel like, oh, there's not many options provided. And there are options provided. For simplicity case, you can make it fewer options or more options. And then we go ahead and get that started. It's still not in a provision state right now. And then you can see that, yes, now the network 2 is a success and it's provisioned. So now your private network is actually deployed. And what you can now further do is provision the SIM file. So if you have an existing SIM management platform, or you can pick a SIM management platform from the marketplace. But for now, we will just take that you have a SIM management platform, the SIM files are taken out, and you can use that to configure the subscriber management system, which is actually deployed on the private network. And once that is there, your private network is up and running. All your devices now have connectivity, and you're able to now just monitor the network. You can also create custom dashboards on this one. You create some of these dashboards so that you can provide some views to the enterprise so that he can see what the status of his private network is and if things are working well or if there's any glitches. And that's how we provide a simple automated private network deployment, management, and monitoring. In order to learn more about monetizing the enterprise services, go to affirmnetworks.com or reach out to your account teams for more information on how to leverage the edge compute, carrier edge extension, private networks, and Slice as a service. Thank you for your time.
Thank you for that very informative discussion on monetizing and profiting from enterprise services. Such exciting times with a new technology that is bound for endless possibilities. And we look forward to many more scenarios we can unlock together in this new 5G low latency compute world. That wraps up today's program. We hope you've learned and enjoyed the sessions brought to you by Microsoft and Globe 5G Hackathon. Until the next enablement workshop, stay safe and have a great day.
We're creating an entirely new class of microcontroller. They bring the same processor core that we've seen in smartphones and bring it down into a single chip package for the very first time.
We feel very strongly that we have now provided the foundation of cloud connectivity and security using Azure Sphere. And with that, we believe now, together, we have a springboard for the future.
Azure Sphere builds on decades of Microsoft's experience in security, in productivity, and cloud-enabled capabilities.
Of course, price is at the core of the microcontroller. These are single-chip computers. Azure Sphere has to reach this very, very low price point.
If you are an original device manufacturer and you're already investing in a microcontroller in your device architecture, then with very little additional cost and with low complexity, you can adopt Azure Sphere technology.
Anyone who is building a device should have a no-compromise view on security. The goal for our product is to make this a reality for everybody.
Security is foundational. Azure Sphere security starts in the silicon and continues through the operating system and the cloud services. Experience has taught us that every component matters because your security is only as strong as your weakest link. Connectivity to the cloud creates for the very first time a connection between the device manufacturer and the device. And more importantly, a direct connection to your customers through that device.
It's getting harder and harder to find the software developers that can develop productively for legacy microcontroller platforms. One of the most fundamental behind-the-scenes benefits of Azure Sphere is that it brings the whole Visual Studio ecosystem into the microcontroller space.
What excites me most about this project is the scale. It is billions of new devices every year. And what we have is the capability of bringing and connecting all of these devices to the cloud, enabling new, rich experiences that are going to affect every person and every organization on the planet.
With Azure Sphere, we fully expect to be surprised by the innovative ideas that you invent for the world and for your customers. I can hardly wait.
It's impossible to look away. Every sense is captivated, pulled into the dance of color unfolding before you. This is the unique immersive experience that customers see when they enter a Microsoft retail store. Over 80 of our locations welcome customers like this, with a huge array of video walls. The content displayed on these screens is constantly being updated to highlight new products and campaigns, but updating the content this frequently comes with a lot of challenges. The layout of screens is unique to each store, and filling them requires imagery tens of thousands of pixels wide or tall. A ton of computing power is required to work with this scale of visual content. During the production phase, designers need to preview and iterate on their work. When everything is finalized, each video needs to be rendered, split into sections, and encoded for each and every store. And the entire process requires a massive amount of storage for the many high-res assets, images, previews, and final videos. Originally, we used an on-premise render farm for this, but it was a ridiculous waiting game, up to 2 days in limbo while the video files were rendering and encoding. And if we needed to change anything, boom, clock resets to 0. Our timeline for each new video was a painful 12 to 14 weeks. We needed a flexible, scalable, cloud-based solution, one that allowed creatives to actually be creative while delivering to Microsoft's unique store configuration. We looked into third-party solutions, but they didn't satisfy our needs. Then, the team had a light bulb moment: Azure Batch. With the ability to run design, rendering, and encoding applications in the cloud, it was a perfect fit. So we engineered a workflow with Azure Batch to automate production and rendering, and the results are game-changing. Batch can duplicate the power of hundreds to thousands of on-premise render nodes with virtual machines. The actual process of rendering is computationally intensive. There are many frames, and each frame can take hours to render. With Azure Batch, we can split a job into many pieces, rendering the frames in parallel across multiple VMs and completing the entire process much faster. And with applications like After Effects, Maya, and FFmpeg running on the VMs, we can extend the power and scalability of Azure to every stage of production. On the front end, we use Azure to host a web-based application that lets designers upload assets, arrange layouts, preview results, and finalize content. Before, designers might sacrifice great ideas to avoid a 2-day render, but with the wait time reduced to as little as 30 minutes, they have the freedom to make revisions on the fly and distribute them faster than ever. Virtual machines are created on demand and spun down when the work is finished. Dashboards enable real-time performance monitoring. Hardware specifications can be changed with a couple clicks, and exabytes of capacity on Azure Blob Storage allow the finished files to stay in the cloud, letting us push videos to every store in a matter of hours, not weeks. In total, we cut production time to as little as 2 weeks and reduced operating expenses by nearly 75%. It really is a revolutionary workflow for anyone producing large-scale content. Whatever the application, Azure Batch can make it happen faster than ever before. For us, that means we can focus on creating a stunning customer experience, with everything automated in the cloud.
Microsoft Azure is a private and public cloud platform. You may be familiar with the Azure services that developers and IT professionals use to build, deploy, and manage applications. But how does it work? Azure uses a technology known as virtualization. Virtualization separates the tight coupling between a computer's CPU and its operating system using an abstraction layer called a hypervisor. The hypervisor emulates all the functions of a real computer and its CPU in a virtual machine. It can run multiple virtual machines at the same time, and each virtual machine can run any compatible operating system, such as Windows or Linux. Azure takes this virtualization technology and repeats it on a massive scale in Microsoft data centers throughout the world. Each data center has many racks filled with servers. Each server includes a hypervisor to run multiple virtual machines. A network switch provides connectivity to the servers. One server in each rack runs a special piece of software called a fabric controller. Each fabric controller is connected to another special piece of software known as the orchestrator. The orchestrator is responsible for managing everything that happens in Azure, including responding to user requests. Users make requests using the orchestrator's Web API. The Web API can be called by many tools, including the user interface of the Azure portal. When a user makes a request to create a virtual machine, the orchestrator packages everything that's needed, picks the best server rack, then sends the package and request to the fabric controller. Once the Fabric controller has created the virtual machine, the user can connect to it. Azure makes it easy for developers and IT professionals to be agile when they build, deploy, and manage their applications and services. But this agility can have unintended consequences if unauthorized resources are created, or if resources are left running after they're no longer needed. The solution to this problem is to use Azure's Resource Access Management tools as part of your organization's governance program. That's the subject of the next video in the series.